And welcome everybody to CCNA Sunday. It is fabulous to have you here. I really am looking forward to each and every one of these sessions. I take a shower, I prepare some content, I lab it up a few times, and I'm super excited almost every single time about sharing it with you. Our objectives in this CCNA Sunday are pretty specific, and that is, what is this whole discussion about default gateway or default route, or when do they apply and how do they apply? In this short, impactful session that you and I are going to have right now regarding default routes and default gateways, I'm going to share with you what I wish somebody had shared with me probably a couple decades ago when I was first learning about this. Because sometimes we just learn, we hear concepts and we kind of like, oh, I kind of get that. And then we muddle it through, and then later it becomes useful. And then I really need to dig into that. So I would like to clarify that with this discussion. And then at the end, we'll open up for Q&A. And also my son is in town, Paul. He's 29, fantastic kid, great, amazing programmer. We stayed up to like 1 a.m. sitting in the car. We went to a show last night, sat in the car and just chatted for till I was close to 1 a.m. And so I'll share you some of those details and some of those insights that I am learning from my son after the presentation. And then we'll go to Q&A. We'll have a good time there too. All right, so without further ado, let's take a look at the whiteboard. So here's the beautiful whiteboard, and we have a bit of a problem, and I'd like to share with you what that problem is, and then of course we'll solve it together as I bring out a writing utility. Okay, so default gateways versus default routes. Let's talk about this topology. This is a fantastic topology. Here we have a PC. Now this PC is just representative of any device on the network. It could be an Android device, it could be a wireless device, it could be, this is in this case wired, but any device that's connected to the network has an IP address. So this network right here is the 10.0.1 network, and this host address right here on PC1 is a .10. And it's happy, and I'll tell you why it's happy. It's happy because it has an IP address. So if it's on the 10.0.1 network and its host address is .10, it's happy because it has an IP address. It knows that the first three numbers, 10.0.1, are the network, and the last number is the 10 because is the host because of the mask, the 24-bit mask. So join us for Subnet Saturdays for all that detail. And then it also has a default gateway, which is going to be right here. Now, one of the questions is, why does a customer or why does a client need a default gateway? And one of the things that I've said this a few times in a few different places is the concept of an Obi-Wan Kenobi. Basically, PC1 says this. Let's imagine over here, what is this PC? What is this network here? Let's go take a look at router 4 and find out what this network is, because I don't remember off the top of my head, but we have tools and we can go ahead and use them. So let's make a road trip over to R4 and do a show IP route and see what he's directly connected to on gig 00. And to do that, I will bring up this window. Boom, right there. I will authenticate again, which is a fancy way of saying log in. And on router 4, we'll do a show IP route. I'm excited to find out what he's got there. So gig 00, was that the interface? Give me a second. Yeah, gig 00 on router 4 is this bad boy right here. All right, so that's the 10.04 network. And this is really important too. The reason that this router 4, believes that he's connected to network 10.04 on that network is because somebody, could have been me, went to interface config on gig 00 and gave it an IP address of 10.0.4. something, and it's right, .4, and with a 24-bit mask. And then the router said, great, I get it. This is network 10.04, and I'm directly connected to it. I can route for that network. Okay, so that was a little segue into what that network is. Let's go back to our topology. So back in our topology, and let me get my pen out. If PC1 wanted to reach this PC4, and I got to bring out my pen tool. And if PC1 wanted to connect to or ping over here, it would need to be able to reach the 10.0.4 network, and with a 24-bit mask, and also whatever the host address is on .4. Let's imagine it's probably .10. Well, we can verify that too. But if we wanted to do that, here's what would happen in the mind of this PC. This PC, if this is the protocol stack, so we have the application layer, and then we have the transport layer, and then we have the network layer, and then we have the data link layer, and then we have, and I'll put an L there, and then we have the physical layer. And these are just ways of thinking about how this operates logically. So if PC1 does a ping, and you and I we've been through a few sessions together, so now we can talk about, not every application, not everything that comes out of your computer is going to use the full protocol stack. So when PC1 does a ping, and he then types in ping space 10.0.4.10, we'll imagine that that's that IP address of this PC. Ping doesn't use application layer services. There's nothing there. It doesn't use transport layer services. Nothing there. It does at layer 3. This is at layer 3, layer 2, and layer 1. Here, it does use ICMP as part of the ability to do a ping. So behind the scenes, if we looked at ping packet, it would have an ICMP protocol that's being used. And PC1 would say, okay, I'm trying to reach 10.04.10. I'm on 10.01. So it's like I'm on street A, says PC1, and I'm trying to reach street E. And as a result, it knows it's not local because it's looking at its network address and says my destination is different, and it will have to use the default gateway. So the client is what's going to do. It's going to go ahead and determine the layer 2 address of its default gateway. And the best way to learn about your default gateway, like what it is probably through DHCP. So when this client booted up, it did a discover, had an offer, made a request, there's an acknowledgement, got an IP address, and the options including who's your default gateway. So PC1 knew that its default gateway was 10.0.1.1, if that's what it is, which I believe it is, and did an ARP request if it didn't already know the layer 2 address. And then when the packet was sent, the packet is sent layer 3, the source would be 10.0.1.10. That's the source address. The destination would be 10.0.4.10, if that's the IP address of PC4. And that would be in the layer 3 header. So if we looked at the protocol analyzer, it'd be right there. It would just say source address is this, destination address is that. But the PC knows that to move a packet or forward a packet to 10.04, which is on a different network, it's going to need a little help from its default gateway. And that's this guy R1. So at layer 2, it would look like this. MAC address of PC1, whatever that happens to be, that 12 hexadecimal character address, which is 48 bits in binary. And the destination for the layer 2 address would be the default gateway. So we'll put R1 gig 0/0. And you can thank me later for not writing in all 48 bits or even the 12 hexadecimal characters. So what happens then is our PC1 encapsulates that. Encapsulation is a fancy word for saying it wraps it up with that information in those headers. So in the IP header, it puts this, PC1 does. In layer 2 header, it puts this, and then it spits them on the wire, like Morse code, bit at a time. And those bits are then received at the switch. The switch plays a little game called How Do I Forward? And layer 2 switches make forwarding decisions based on layer 2 addresses. So the switch, this is a great review, by the way. I appreciate you being here. You're fantastic. The switch is going to look at the layer 2 destination MAC address and say, do I know where that is? And the switch is going to say, yeah, I know what port that lives off of because I'm dynamically learning MAC addresses. I'm a switch. And so the switch very quickly, I mean, we're talking fast, forwards that frame out to this port, whatever that port is on the switch, over to gig 00. Router 1 sees it. It sees, hey, this is addressed to me at layer 2. Opens it up. I mean, it's like getting a piece of mail. If you get a piece of mail and it's addressed to you, you open it up. And so at layer 2, that layer 2 address has the layer 2 address of gig 00 and R1. So it says, hey, this was sent to me. It could be important. What is it? I don't know. It's curious. It's a curious router. So it opens it up and then looks at layer 3 and says, oh, this is coming from 10.0.1.10. It's going to 10.0.4.10. Oh, that's not me. But I'm a router, and I'm willing to route people's packets on their behalf and forward it. So this router, if he has a route in his routing table, he will make a forwarding decision. And in this topology, we have 2 paths, and I think they're worth drawing out. We'll go ahead and use path A, which from router 1's perspective would be this route. You take the high road, and I'll take the low road, and I'll meet you in network 10.04 before you. That's why I don't have a singing career. All right, so this is path A, and we'll put path B in a different color. We'll use, how about green? Well, not green. Green is too like it's good. We'll use, how was the live stream today? Great. I just couldn't decide on what color to use for path B. All right, here's path B, which would go from router 1 down here, and that would be path B. So my question to, and let me give you the details too. This path here in all the green links, those are fast gigabit Ethernet, 1,000 megabits per second, or gigabit. And then the fast Ethernet is 100 megabits per second. So the green links are 10 times faster than the yellow links. So I have a question for you. I'd like to pause for a moment and share the screen with you and look at the chats just for a moment and have you and ask you, which is the better path? Which route should R1 take? Because it's a routing decision at this point. Should R1 forward on path A, or would it be better to route and forward on path B? And I'll give you a moment to think about that. I love it. I know I'd love especially the fact that we're putting all these concepts together. So we learned a lot of basics on the road here together. We've had a lot of good times in the master playlist, and now it's focusing on learning new things still, and also applying all of them holistically together. All right, I'm going to move my mic over a little bit and look at the Q&A, and I have people saying path A. Oh, I've got a lot of everybody saying path A. Wow. Okay, just a ton of votes for path A. And I'm going to say that's a smart move. Path A is gigabit all the way across, and path B has a fast Ethernet, a bottleneck in the link, and as a result, path A would be faster. Yep. And so we'd want to run a routing protocol. This is a chance where ospf would be preferred over a distance vector routing protocol like RIP. See, RIP would treat those as equal costs because it's the same number of routers to go across. It wouldn't know the difference. And ospf would use path A. So we'll just take path B out of the mix. I agree. That's the best path. And so R1, when he has his packet, he would then forward it on path A, and he would forward it in the direction of R2, assuming that's his route that he's going to use. And to do that, what he's going to do, and I'll put a line here, R2 is going to, back up. What R1 is going to do, he's going to say, okay, I'm going to continue, I'm going to forward this packet over to R2. So when R1 forwards it, the source address is going to be 10.0.1.10, still coming from PC1. And the destination is still going to be 10.0.4.10, because that hasn't changed. So that's the destination. But what is going to change is R1 needs to forward this to the layer 2 address of R2. So the source MAC address at layer 2, if we were to look at it on this segment here between R1 and R2, R1 is going to put, when it encapsulates it and it rewrites the layer 2 header, the source MAC is going to be R1, and I will put gig 10, because that's literally what it is. And the destination layer 2 address, I'll put source here, source layer 2, destination layer 2, and up here we have source layer 3, destination layer 3. And the destination layer 2 address would be this bad boy right there, R2's gig 20. So, I got destination layer 2, and I'm going to put R2 gig 2/0. All right, and then we play this really cool game where R2, and just to make sure we don't miss any pieces, when R1 forwards that into the switch says, I'm a layer 2 switch, and I'm going to move frames based on layer 2. So it looks at the destination layer 2 address, says, I know where that lives, and it forwards it over to the right port. R2 gets it, says, hey, this is for my layer 2 address. It's curious, opens it up, sees that the packet is destined at layer 3 for 10.0.4.10, and it makes a routing decision. It rewrites the layer 2 header. It forwards it to R4 if that's the path it's going to use. Then R4 takes it, does the same game. Looks at the layer 2 destination address, saying, this is me. Great. Opens it up, looks at the layer 3 destination IP address, and then makes a forwarding decision over in that direction. Switch is going to make layer 2 forwarding decisions, and then finally it reaches PC4, and PC4 says, hey, this is for my layer 2 address, because the local router here put the correct layer 2 address for the final destination. And then as PC4 opened that up, it said, hey, this is for my IP address. I'm still interested. So it opens up the IP packet, and in that IP packet, it is ICMP, and it's an ICMP echo request, meaning, hey, how you doing, says PC1 to PC4. Hey, how you doing? Are you there? Can you respond? And at which point, PC4 will send an ICMP echo reply. It's the reply portion of a ping request. And then that whole process goes in reverse, where PC4 puts the layer 3 address of PC1, and then for this first hop, it's going to put the layer 2 address of its default gateway, and that packet gets forwarded. All right, so that's a little warm-up exercise for the discussion of default gateways and default routes. And here's how it works. You're going to love this. Let me clear off this board. And let me give you a nice clean picture with the default gateway versus default route. So we've digested, we've ingested this, we've enjoyed it. That's great. Let me go ahead and clear it off. And that's going to be done with this button right here, all that work, as I continue to talk into the mic. There we go. Okay. There's a choice that all these devices regarding layer 3 are going to make. And we'll pick on the PCs and the routers for a moment. It is, do I want to route for myself? Or do I want to route for myself and others? And if you have a device that's routing just for itself, it's going to be using what I call the Obi-Wan Kenobi route. Its default gateway. And let's focus on a PC for a moment. Does a PC have a routing table? The answer is they do. We don't often think about it, but your PC knows it's directly connected to this one does, that is directly connected to the 10.0.1 network. If we did a route print in Windows, it would show us its routing table, and it would show a directly connected route right there that we are directly connected to 10.0.1. So they have a routing table, but PCs by default aren't built to take a packet from somebody else and route it for, continue to route through the network. Now you can configure routing on like a server, although it's not preferred to do. You can train like a Windows device to go ahead and be a router for other people's packets, but end stations are primarily thinking about themselves and they need to forward traffic. So if you have a device that's not routing traffic for other devices, it's just routing for itself, like I need to forward traffic, it has a routing table. It knows the directly connected network. That's how it knows if it's talking to other local devices. It doesn't have to use the default gateway. And if it's trying to forward a packet somewhere other than local, what it's going to do is going to resort to its default gateway as a gateway of last resort, meaning, okay, this is PC1's attitude. I'm trying to forward a packet to 10.04, and in my routing table, which is very limited on an end device. You can tweak it, but that's beyond the scope of this discussion. But the routing table on the end of PC1 is very limited. So it says, okay, I don't know where to go, so I'm going to use my default gateway, and it's his problem or her problem. That's literally how it works. These packets that are being sent, PC1 is just hoping that if it encapsulates at layer 2 and puts the router's its default gateway's layer 2 address, that here, it's like hot potato. Here, Mr. Router, have it. Hopefully you can forward it based on its layer 3 address, and hopefully the router can. That's our job as network engineers, to make sure that our routing topologies work, that we have routing protocols running or static routes, and for IPv4 or IPv6 to make sure that once clients hand off that IP packet over to their default gateway, that packet can be routed. So anytime you see the idea of a default gateway, I would like you to think that's a device that is routing for itself, meaning it's looking out for itself, and if it doesn't know how to forward a packet in the right direction, it'll just hand it over or forward it to its default gateway. Help me, Obi-Wan. You are our only router. Think default gateway. That's it. Routers can have this opportunity too, and I'll show you that in just a moment. But so I'm going to stick with the default gateway first. Secondly, if we have a device that's routing for itself and others, it's going to be using routes. And if it doesn't have a specific route for how to route, it's going to use what's called a default route. So here's what that means. If we have a device, and I'll put these in two separate colors. If we have a device that is routing for itself, meaning it's not forwarding on the behalf of other people's traffic, it's going to need a default gateway if it ever wants to forward a packet off of its local network. I mean, clients don't have to have a default gateway, but if they ever want to forward a packet somewhere other than their local street, they're going to need one. And so if a device that's routing for itself, it's going to need a default gateway to forward to in the event it has not a local destination. So self. And if you have a device that's routing for other devices like a Cisco router or other network devices like that, it would have a default route I'm going to say others. It's going to have a default route, which is similar to a default gateway, but it's part of a bigger routing table picture. So we could say that this router right here, R1, if it's enabled for routing, which it is, meaning it can route for itself. Like if you were sitting at R1 and you did a ping, it would forward its packet based on its routing table, so it's routing for itself. And if PC1 forwards a frame to it, because it's routing for others, it's configured with IP routing, that's how you enable it, it would go ahead and look at its routing table for a match. Do I know how to forward this packet to 10.04 in this case? And if it does, it'll forward based on that information. But if it doesn't, it can have a default route in its routing table. This is the equivalent of a default gateway for a device that's routing on its own. But default route is simply a route in the routing table that says, hey, Mr. R1, don't be so hard on yourself. You got this packet for 28.17.19.40. If you don't have a route in your routing table that says how to get to that network, I want you to default back to this default route, which says, if you're not sure how to forward this, Mr. Router, I know you're helping other people out, use the default route. That's literally how it works. It's the last ditch effort. When the router doesn't find a more specific route in its routing table, it uses the default route. And in Cisco, it looks like this. You see 4 zeros like that? Yeah, I won't add that in. That's just beyond the scope of what we need to talk about. But 0000 indicates a default route. So we're not looking, if we have more specific routes, it'll be used, but that's a default route. So I thought it'd be really cool if we demonstrated all of this, and it's pretty easy to do. So a couple things before we go to the live demo is, if you have a device like a PC, an end device, a device that doesn't route for other people, that device still needs to know how to forward packets to devices that are not on the local network. If you have a device that's willing to route for other people, other devices, like a Cisco router or a multi-layer switch with IP routing enabled, then it's going to have a routing table, which you can add static routes to. We can train it with dynamic routing protocols, and we can configure a default route dynamically or statically. And that default route is simply going to say, hey, Mr. Router, I know you're routing for other people. If you don't know how to forward a packet because you don't have a more specific route in your routing table, just go ahead and use the default route. And that's the difference between a default gateway, where a device is not routing for anybody else except itself, and a default route, where you have a device that is routing for other devices and it doesn't have a specific route. Before giving up, it can use the default route and use that to forward the packet and layer 2 information to the next hop. Okay, so there is a little bit of an opportunity here for discussion, and then we can demo it, is that on a Cisco router, by default, it has this feature called IP routing enabled. And bada bing, bada boom. That's what enables IP routing on a Cisco router, and they turn it on by default, because if it wasn't, Cisco TAC would get thousands of calls saying, I just configured my router, it won't route for anybody. So you have to enable IP routing, and it's on by default in Cisco IOS. Now, on a multi-layer switch, depending on the multi-layer switch, you may or may not have IP routing enabled. And on a multi-layer switch, which can do layer 3 routing and layer 2 switching at the same time. We've talked about those in previous videos in our master playlist. If IP routing is not enabled, that multi-layer switch will not route for anybody. And if you have a switch that is IP routing is not enabled, you need to configure a default gateway. So it can say, okay, I'm just routing for myself. I've got no routing table because routing is not enabled. If I need to forward packets to a remote network, I need to have a default gateway. So in a multi-layer switch, you're saying, Keith, that in a multi-layer switch, if IP routing is not enabled, that you need to have a default gateway so that that device, that switch itself, can communicate to remote networks. Yes, absolutely. And if you have a layer 2 switch that doesn't support any IP switch that doesn't support IP routing for other people, that layer 2 switch also is going to need a default gateway. And I remember when I first learned this, I thought, why? It's a layer 2 switch. Like, he's just forwarding frames. Why does this guy need to have a default gateway? Anyway, I mean, it's just a layer 2 switch. Let me show you. Let's imagine together, as I bring my mic over, let's imagine that this device right here, Core 1, is a layer 2 switch only. And let's also imagine, for discussion purposes, that it's not doing routing for others. No routing for others. And we can do that on this switch by simply saying no IP routing. And let me back that off. So if we do no IP routing on this switch, this multi-layer switch, it's going to be effectively a layer 2 switch only, no routing capabilities for other devices. So to test that out, let's go ahead and let's go to live interface. Let's take a look at core 1, and I'll show you measurably the difference between IP routing and no IP routing, which will help confirm our situation where you're willing to route for other devices. And let's go to this core 1 switch. Great. So if we did something like this, let's do a config T and say no IP routing. So this is a multi-layer switch, but what I've just done is with this no IP routing command, it's effectively the same as a layer 2 switch, only it will not route for other people. So if we do a do show, and I'm doing the do because we're in configuration mode and I don't want to have to exit config and do the command and then go back. So you just tack on a do in front, and that automatically allows you to do the do command, the show command. But it doesn't always give you the context sensitive help, so it's a trade-off. So if you know the command, you can just do the do in front. So show IP interface brief. So this switch at the moment has no SVIs, no layer 3 logical interfaces. So if we wanted to communicate with this switch via IP, we can't. It just doesn't have one. So if we want to give it an IP address, and this is effectively a layer 2 switch at this moment, let's give it an interface in VLAN 1. Let's first of all do a show VLAN brief. I want to make sure what VLANs we have. Great. So we've got VLAN 1. And for those of you who know, this comes for free by default. All the ports by default are in VLAN 1 until you start carving it out. So we have VLAN 1. That's the VLAN, the layer 2 broadcast domain. And all the ports, it appears, right here, are associated with that VLAN by default, which is great. So let's create a logical layer 3 interface on this layer 2 switch. Now you might say, Keith, why? Why? It's a good question. Why? Why are you doing that? Why, Mr. Grinch? Why? Well, the reason we're going to do that is because if this is the management PC right here, let me get my face out of the way. If this is our management PC right here, and we want to manage this switch, and again, at the moment, it's going to be just a layer 2 switch. If we open an SSH session, so we type in SSH, or we use our PuTTY client or secure CRT, and we connect over to the core switch, we've got no problem getting there. We're on the 10.0.1 network. We use our default gateway. He forwards it to the IP address that we're about to put on the switch. But if this switch gets that packet and says, "Oh, I'm getting I'm getting an inbound management connection." And this could be from our SSH session, or it could be from an API, from software-defined networking, whatever. The switch says, "Hey, this packet is coming from 10.0.1.10. I would love to." This is what the switch is saying. I would love to respond to that. I would love to reply back and establish this session with the management station, but I have no idea on how to forward packets outside of my local network. And you know why that is? We ask the switch, and the switch will say, it's because I don't have a default gateway. So if you have a switch, a managed switch, meaning you're going to remotely connect to it, meaning you connect to it from any other network than the local network it has the VLAN interface on, we need to make sure that it has an IP address in that VLAN, and we also need to make sure that that switch has a default gateway configured. Not a default route, but a default gateway, because it's not doing IP routing for others. It's only routing for itself. So let me walk you through how that would look. We would simply go to the switch, and let's make a plan here. Let's say the switch is going to be, we're going to make a VLAN interface. So the actual syntax would be something like this. Interface, VLAN 1, enter. We'd say no shutdown. If, in fact, it was going to be down by default, which on this model it is. And then we give it an IP address. And we have to give it something on the 10.0.12 street. So let's do 10.0.12. And let's go ahead and use, let's use something I can remember. Let's use 111 with a 24-bit mask. So that would make Core 1 have a management IP address on its VLAN 1 interface, not for the purpose of routing for other people's traffic, just so we can remotely connect to it. And then once we have that IP address configured, then that Core 1 device can talk locally on that network, but it doesn't have a default gateway. And if we want it to be able to communicate back to the management PC, we need to tell Core 1 that its default gateway is going to be either R1 or R2. It really doesn't matter because R1 and R2 both know how to route packets to the right destination, but in this topology, probably gig 010. So we exit out of interface configuration mode for this SVI, which is what that is, a switch virtual interface. And then in global config, we'd simply say, I think its syntax is IP default tab is default gateway, but you just simply tab it out. It's going to be unique, that part. So IP default gateway, and then you specify the IP address of R1, and R1 is 10.0.12. and it's .1. Press enter, and now this layer 2 switch has a IP address on its switch virtual interface for VLAN 1, and if it ever needs to respond or reply or reach destinations outside its local network, it's got a default gateway. This is all about right here. The default gateway, it's just like this PC that has a default gateway that says, if I don't know how to forward a packet, go ahead and use your default gateway. With a switch, a layer 2 switch, or a layer 3 switch with no IP routing, it is the same exact behavior. This is the go-to guy when Core 1 needs to send a packet outside of the local network. So with that said, let me hide that for a moment. I'm going to not erase it yet because we may need that again. And let's go configure this. Let's start on Core 1 and do our work, including the default gateway. So do show IP. I'm typing, but nothing's happening. There we go. Do show IP interface brief. Just want to verify that we don't have any SVIs yet. If we did, they would show up here, whether or not they're configured, but we have none. So we'll create interface, I'll tab this out. Interface VLAN 1, because that's the only VLAN we have, and that's also the VLAN that R1 and R2 are using. This puts us into interface configuration mode for interface VLAN 1. And from here, we'll go ahead and bring it up with a no shutdown. It'll be up in a moment, and then we'll give it the IP address based on our plan of 10.0.12.111. And then we have a 24-bit mask that we agreed to. I say we agreed. In my plan, that network is a 24-bit network, so it's a good idea if everybody else on that network believes it's 10.0.12. We want to make sure that this device is going to comply, so this is what we'll do. So there's 8 bits of the mask. There's 16 bits of the mask. There's 24 bits of the mask. And the last 0 simply means that's where the dividing line is. So 24 bits of network and 8 bits available for host addressing, which means this host address is 111. If you're new to subnets and IP addressing, check out the Subnet Saturday playlist from soup to dessert. You'll have a good time, and you'll be a master at this stuff before long. All right, so it's got an IP address. What's the next thing we're going to do? What is the right thing to do after we make a configuration change? And in my mind, I'm thinking we verify it, because I've done commands before and then it didn't take. Like, which device? So just take a moment and let's verify that real quick with the do show IP interface brief, just to verify that that interface exists. There it is, and also just to verify that it has the IP address and that it's up, and that looks great. Also, I see in the corner of my eye, I see the queue over here for questions. And just to so you know, at the end of the stream, at the end of the presentation regarding default routes and default gateways, I'll go ahead and we'll focus on Q&A. So any questions you have now for me, please hold those or be ready to re-put them in so I can see them at the end, because I don't want to miss a question, and I appreciate all of it, and I don't want to miss anything. All right, so now we've got an IP address. So let's verify what we could do with it. Now, let me erase that. So this PC, the switch, has the IP address of 10.0.12.111 with a 24-bit mask. Fantastic. So what it should be able to do, it should be able to ping R1's gig 1/0 interface address of .1, and it should be able to ping R2's gig 2/0 interface of .2, but it should not be able to ping or have reachability to anything out of this local network. And that is because it has no clue, with no routing table and no default route, no default gateway, it has no clue how to reach any networks outside of 10.0.12. So if we tried to ping over here to 10.0.1.10, it would just fall on deaf ears, because Core 1 would give up. It would just not even try to send the frame. It would just say, don't know how to get there. And it wouldn't send any traffic whatsoever. So we'll solve that with the default gateway coming up, but let's do our pings first just to verify. So back in the interface, and I guess we can exit out of configuration mode. It's very easy to go back in. So do a ping to 10.0.12.1, which is the IP address of R1 on that 10.0.12 network. Fantastic. And then we'll do a ping to 10.0.12.2, which is the IP address of R2. Fantastic. So this is in a lab, all virtualized, so it's taking a little bit extra time. Shouldn't normally take that long. But anyway, there we go. So we have pings to both sides, but if we try to ping the PC, let's verify what that address is. The PC is at 10.0.1.10. If we try to ping that address, it is going to not be so happy. So 10.0.1.10. And if we did a debug on that, it just has no ability, no idea of how to get there. So what? Wait, 10.0.1.10. Hold on 1 second. Show. How did you get there? IP route. So because we have IP routing disabled on this switch, there's no routing table. Why is it getting there? Oh my gosh. Hold on 1 second. Show IP default. So the default gateway is not set. How in the world did you get there? All right, so honest to goodness, I need to look at why that's forwarding. Routing is not enabled. Let me. I am so curious. There's no. Here's the deal. This is a layer 2 switch, and the show IP route verifies that. Show IP route. If routing was enabled, it would do a show. It would be a show the routing table, even if it was empty. Let's. I'm literally curious on how the heck Core 1 was able to forward a packet. And let me see if I have debug capability here. I do. Let me do this again. Let's do a show IP interface brief. I'm curious. 10.0.12.1.1.1. That's definitely the 10.0.12 network. And if we look at R1, show IP interface brief. So he's at 10.0.12.1. That's that interface connecting. How in the heck did that work? Unless I have something on the back end set up incorrectly. Let's do this. Let's do a show ARP. That shouldn't have worked, by the way. Oh, right there. No, I'm puzzled. All right, so let me put my hat on here. 10. So in the ARP cache, what this means is that this device tried to ping 10.0.1.10, and he did an ARP, and somebody responded, oh, it's probably, whose MAC address is that? 1C, oh, it's R1. So what is happening? I wasn't expecting this. What's happening in measurable terms here is that R1 is responding on behalf of this address. Oh, it's proxy ARP. That's what it is. Oh my gosh. All right, I'm going to disable proxy ARP on interface. Boy, I wish I'd seen this before I did the live stream. I just would have removed the issue. So let's talk about this for a moment. Here's what I think is happening, and then we'll test it out. This is how it goes sometimes when you lab things up and you practice it. It's like, wow, look at that. So the switch did an ARP request. Why would it do an ARP request, though? 10.0.12. Did I put the right? So the switch, I'm looking at my network. So the switch is on the 10.0.12 network. And when it's looking for, oh, it's doing proxy ARP. Wow. Okay. In a normal environment, you wouldn't be able to reach anything outside of your local network. But what's happening here is that this switch, without a default gateway configured, it is doing an ARP request for a non-local IP address. That's what happened. It did an ARP request for 10.0.1. .10, excuse me, for the host address of the PC1, and router 1 said, you know what, I'm a router, and I see you're doing this ARP request, and what I'm going to do is I'm going to go ahead and say that's me, and then I'm going to go ahead and forward it because I know where that route is in my routing table. Boy, this is not CCNA material anymore. This is not your grandfather's situation. If these were just normal devices, they wouldn't be playing that game. Let's disable it. I'll show you how to do it. So let's disable it. Okay. How do I disable proxy ARP on that interface? Because it's a, wow. Okay, let's go to the core switch and do a config T interface and VLAN 1 and no proxy. Nope. All right, how do I disable proxy ARP? No IP. Oh, proxy ARP right there. No IP proxy ARP. So I'm going to turn it off here, although I think I really need to turn it off on R1. There we go. So I just turned off proxy ARP on this switch. Now, in testing, it's not a good idea to change 3 things and test it. So what I'm going to do here is I'm going to shut down the VLAN 1 interface, bring it up now that proxy ARP is no longer enabled. And my belief is that what happened is because we had no default gateway and proxy ARP was enabled, it went ahead and, we'll verify this in a moment, it did an ARP request for a non-local address. R1, who also has proxy ARP enabled, said, yep, I see you're ARPing for this non-local address. I have it in my routing table. I'm going to route it. Wrong. Shouldn't be doing that. I mean, it's literally happening, but it's not nice and clean for CCNA. So let's fix it. I'm also going to make the other change here on router 1. Look at its interface real quick, which is gig 1/0. I'm going to turn it off there because that's also part of the problem. Config T interface gig 1/0, and you are here for the ride, my friend. No IP proxy ARP. All right. Actually, I'm gonna go back and interface gig 1/0. Shut. That's the great way to remove all the ARP cache entries, by the way. I also killed my ospf neighbors, but they'll be back. All right. And we'll go to the core switch, show ARP. See here, right here, because it still has it in its ARP cache, it'll still use it. And so what we're going to do is we're going to go into interface. If we just do a clear ARP, what happens is not as nice as what we'd think. If we do a clear for the ARP cache, it doesn't actually remove the entries. It'll just reset them to a timer of 0 like we just learned them. So I want to take the interface completely down and then bring it back up, verify the ARP cache, and then we'll do the ping. And it won't work. That's my thinking. All right. So interface VLAN 1. This is the switched virtual interface. We'll do a shutdown, give it a few moments to think about life, consider its choices, wait for the message. Oh, it's coming. There it is. And no shutdown. I'll put some circle cam back on, and then we'll give it a moment to come back up. Fantastic. We'll do a show ARP. Oh, by the way, proxy ARP will not be anywhere near your CCNA certification exam. Okay, great. Great. So this is saying that this interface and this switch knows about the layer 2 address for its own IP address, because it's there, and the ARP cache is clear, and I've disabled proxy ARP. Oh, I should probably disable proxy ARP on router 2 as well. Because let me just do that for safety purposes. It'll save us a trip. So let's take a look at the topology. I'm going to go over here to gig 20 on R2 and disable proxy ARP there. So in the event that Core 1 decides to do a broadcast for a local, for a layer 2 address which isn't local, R2, if he hears it, won't actually respond to it. So I'm going to fix that also. Lab. And that interface is gig 20. So we'll go over to R2. Interface gig 2/0 and no IP proxy ARP. Come on, there we go. Didn't really need to bring it down and up, but just in case. Also, it may take a moment for the neighborships to come back up through their init and two-way, and then xstart, exchange, all that good stuff, and then become fully adjacent. There we go. So we're fully adjacent with R1. Fantabulous. Now, let's do a reset. This core switch is acting as a layer 2 switch now because we disabled IP routing. We have no default gateway configured, and we also disabled IP proxy ARP on all interfaces. So now, if this device tries to go ahead and reach any network that's not local, it should fail. And if it doesn't, we'll resolve that. But we've explained and walked through why it responded through a feature called proxy ARP, and now we'll take a look at how it really should behave in a normal network. And I got a question last live stream is asking, so what experiences or what have you learned in a production environment through some situation that happened? And this is a great example because I just forgot about proxy ARP. I mean, it's in my head somewhere, but I forgot. I think the situation is that if you have a switch that does not have a default gateway configured, by default, it'll do a ARP request for the layer 3 address we're trying to reach, even if it's not local. And then the proxy ARP feature on the neighboring routers, they see that broadcast for the ARP request and think, oh, I have a route to that. I could help you out. They lie. They send their layer 2 address. And then when the frame is forwarded to them, they make a routing decision and forward it on its way. And that's what I've reminded myself of with this lab. All right, so let's take a look. Come on, Core 1. Starting off, we'll do a show IP route. Because this device is not enabled for IP routing, it's not showing us the routing table, which it would if IP routing was enabled. It's just saying that the default gateway is not set, and it shouldn't be able to reach 10.0.1.10. I'm gonna make a really big confession here. I hope this does not work because it shouldn't work. I disabled proxy ARP everywhere. Wait for it. Wait for it. Give up, you stinking. All right. Yeah, it's not going to fly. When they showed up the first time, I was like, oh, great. Is my topology wrong in the background? So what's happening here is we have a frustrated switch. We have a frustrated switch that says, I'm trying to reach 10.0.1.10. It's not local, and I don't have a default gateway, so I cannot reach it. So to solve that, what we'll do, and I'll let that time out, or we could do Control-Shift-6 to stop it. But what we'll do in the background is we will now configure a default route. And we'll tell Core 1 that it's, I shouldn't say a default route because routing is not enabled. It's really a default gateway because routing is not enabled. We'll tell Core 1 to use 10.0.12.1 as its default gateway if it ever needs to forward packets off of its local network. So we'll do that. We'll go back to our interface. And we'll go into configuration mode. And the syntax is IP default gateway. And then we'll put in the IP address of R1, which is 10.0.12.1. Boom. Now, if we do a show IP route, it's going to say my default gateway is 10.0.12.1, and I'm ready to go. So if we tried the up arrow key a few times, and we do that ping to 10.0.1.10, now what should happen is we should be forwarding that to our default router, which we did. R1, because it didn't have an ARP cache entry for the PC, very likely, had failed on that first one. And then it, after it resolved that, was able to forward the rest of those packets. And then we'll just do that again. And we can also do a trace to verify the path. So trace route to 10.0.1.10. That's PC1. And our first hop right there was the router 1. And then our second stop was the actual device itself. That, my friends, was way the heck more than I intended to teach today in this live stream, but we're only halfway there. So if we have a device like a PC or a switch where IP routing isn't capable, it's not built into the feature set, or it's disabled with no IP routing, we need to have or should have a default gateway configured so that if that switch needs to respond or communicate outside its local network, it knows where to forward, and we're not relying on proxy ARP. Which nobody should have seen in this live stream, but it's important to know how it works, and that's how it works. And I'm grateful that somewhere in my history I've encountered that before, because I would be otherwise be, is it broken? All right, that's a lot of fun. So let's turn the tables now, and let's imagine that we have a switch with IP routing enabled. And then instead of a default gateway, which would no longer be used, we are now going to have a default route that we can either add into statically into that router, or we can have it trained via a dynamic routing protocol about how to reach everything. So let's do that. So in our topology, to be clear where we're at, router core 1, we are going to enable the command IP routing in global config, and that simply says, hey buddy, you've got the guts, meaning you've got the internal software to support routing. Let's go ahead and do it and enable it. And then if we do a show IP route, we'll see that we're going to have a routing table entry as opposed to just showing the default gateway. And here we go. So here's before and after picture. Show IP route. Before, we're enabling routing. IP routing, that's the syntax. So there's multiple options that start with ROUT, so we're going to say routing. Otherwise, we'd be adding a static route. So IP routing, and now look at this, do show IP route. I love this part of the play. So what this is saying is, show IP route, here's all the codes for how I might learn routes, says this router. I might learn routes via ospf. I might learn routes via EIGRP. I might learn routes via BGP. Etc. I may learn routes via directly connected networks, which is what that C is right there. So that C says I'm directly connected to the 10.0.12 network with the 24-bit mask, and that's why it shows up as a C right there. And then the L is just for improvements in routing for the local database. So the L is going to spell out a 32-bit route, but it's just identifying the interface. So there's our route to 10.0.12 via VLAN 1. And what that really means at the very end there, that VLAN 1 means interface VLAN 1. That's the interface that we're using, that we're directly connected with. So it's not talking about the layer 2 broadcast domain, VLAN 1. It's talking about the switched virtual interface, logical layer 3 interface called interface VLAN 1. So that's a significant difference. Also, what happened to our default route? I mean, what happened to our default gateway? We configured a default gateway, but because IP routing is enabled, that doesn't matter anymore. Default gateways are for devices that don't route for other people. Now that we're doing routing for other devices with the IP routing enabled, now we have our routing table. And if we want to route, we have 3 ways of adding routes, basically. Number 1, we can add more interfaces, and those will be directly connected networks. Great, that works. We have one here with VLAN 1. Another option would be we can make static routes. And we've had a video or 2 in this segment, in this master playlist about static routes. And that would work. And so a static route could be either a static route that says, to get to this certain network, great, or to get to this, or a static route could say, this is the default route. Those are both options. And then the third option is dynamic learning through a routing protocol. And all 3 options are great. What I would like to do, because we have options with static routes right here, or we have options with dynamic routing, I'm going to put on a little bit of a pause and ask you your opinion on which one you'd like to do. We have 2 choices for getting a default route on this multi-layer switch. We can use a dynamic routing protocol like ospf, which I'd be happy to walk you through, or we could do a static route that adds a static default route. So either way you want to play it, let me know. I'll go ahead and give you a moment to consider that, and I'll look at the first few answers that are typed into the queue. Having a lot of fun. Oh my gosh, what a blast. What a blast. Yeah, give it a few moments. So what we're doing is we're going to add a default route to this device, which is acting as a router now because IP routing is enabled. Also, as you're typing in those answers and as I take a look in just a moment at the queue, on IP version 6, that's also what's going on by default. With IP version 6, IPv6 routing for other devices is not enabled by default on most Cisco platforms. And so if you want to run IPv6, we'd also need to do IPv6 unicast routing, and that's what enables IPv6 routing for other devices. That's why when most people configure IPv6 for the first time, it's like, hey, I'm configuring this. I can ping other devices that are local, but how come this device won't route? It's because routing is disabled by default for IPv6. So IPv6 unicast routing is how you enable routing for IPv6 on a Cisco device. All right, Darsher saying ISIS. Yeah. Well, there's a lot of OSPF, so 90+% is saying OSPF for the win. I'm in. I'm totally in. Totally in. So let's do that. Let's talk about a plan, and then we'll go ahead and implement that plan together. So because you asked for it, because you want ospf, which I think is a great choice, by the way, we need to have some ospf running. So fortunately, in this topology right here, ospf is running already. That means that R1, R2, R3, and R4, they're all running ospf. They're all in area 0. There's some other areas hanging off here also, but for our purposes, we have ospf area 0. Great. And all we need to do is bring in core 1 on VLAN 1 and tell them that we want to play the game of IP routing with ospf. And because we've had other streams on that, I think the actual, well, let's write it out. That'd be worthwhile. So we'll go into core 1. We'll go into configuration mode, and we'll type in router space ospf space and a process ID. Press enter. And then once we do that, we're then going to do a network statement. And because he's on the 10.0.12 network, we could say network 10.0.12.0 with a wildcard mask saying, please match, says the wildcard mask, on the first octet, the 10, the second octet, the 0, the third octet, the 12, and we don't care about matching on the last octet. And then we could put a space, and we could say area 0, just like that. We also could just, put all zeros here and put all 255s here, and that would say don't care about matching on anything, put everything in area 0. He only has one IP address, so anyway we'd do it. And then we could also specify a router ID. In fact, let's do a router ID. And let's make the router ID 111.111.111.111. Also, yeah, that'll work. And then once we do that, core 1, one of these devices, probably R2, is the designated router because it has a higher router ID based on its router ID. And so if they came up at the same time, R2 is probably the DR for this segment. That means R1 is probably the BDR, and that means core 1, hey, for bonus points, what is core 1 going to be if we bring them up on this network segment that has a DR and a BDR already in place? I'm going to let you chat that in. I'll check the queue in just a moment for answers, and then we can verify it together once we go ahead and configure this. So back to the interface we go, adding ospf. Not because I want to, but because you asked for it. And actually, I do want to. It's a great way to go. So we're on core 1, and let's do a do show CDP neighbors, just to verify that we really are connected to R1 and R2. That's fantastic. They are there. And router, ospf1, router ID 111.111.111. We go 111.111. 4 octets is all we need. So there it is. That's the router ID for ospf. And then we'll do a network statement of 10.0.12.0 with a wildcard mask of 0, 0, 0, 255, which means in English, hey, Mr. Core 1, here's what I want you to do, says ospf. I want you to take a look at all your interfaces and their IPv4 addresses. And any interfaces that start with 10.0.12, boom, you're going to have those participate in ospf area 0. And any directly connected networks to those interfaces, whatever the masks happen to be on those interfaces, include those networks also into ospf so they can be advertised and shared with the rest of the ospf network. So we'll press enter, and then we'll wait. And it shouldn't be long. There we go. Because there was a DR and a BDR already present, there's no elections taking place. We are going to become fully adjacent with the DR and BDR on this segment. And we have gone all the way through init, two-way, xstart, exchange, and loading, and full with both the routers, both the DR and the DR and the BDR. We can verify that with a show IP ospf interface brief, which says that our state is the druther, and there are 2 neighbors on that network segment, and that's the count, that's the C. And then this first 2 is how many of those neighbors are we fully adjacent with, and we're fully adjacent with both of those. And we are a DR other, so we do a show IP ospf neighbor, and there's our neighborships. Oh, look. All right, so R1's the DR. So the reason for that would be if they both came up at the same time, if R1 had a higher ospf priority on its interface, that would cause it to go ahead and become the DR if R1 and R2 came at the same time. But if the priorities were the same, then the router ID would be the tiebreaker. And the router ID for R2 is bigger, better, faster, stronger, but The results of this would be because R1 was brought up first, which is true. It has to be true here. If all the other things are equal, and then it established and said, there's nobody else here, I'm the DR, and then after that, R2 is brought up, and that's why R2 is the BDR. That's the reason. And then R3, the switch one, the core one, is just a DR other, meaning I don't get to be the DR, I don't get to be the BDR, I guess I'll do something else, something other, like a DR other. All right, so now, if we do this, show IP route, this is going to be big. You ready? Because it synchronized all the LSAs for area 0 with that area. Oh, my lab closed. You've got to be freaking kidding me. Oh, that's amazing. I have a 2-hour window that I set up on these labs. You know what? I'm going to reset. We can do it. You're going to get a little bit of a redo here. So I'm going to bring up this camera for a moment, and I'm going to just launch that lab again and redo that work. Repetition is the mother of learning. Somebody said that when they had to do something many times they didn't want to. No, repetition is not a bad thing. Let me go ahead and bring that up. A little embarrassing, but fun. Oh, I know what happened. We ran into the proxy ARP issue. We resolved that and went a little longer than I expected. So how many people do we have? Wow, 141 people are live. Thank you. Love it. I am just having a blast. So it says about 1 minute and 20 seconds for this lab to load, which isn't very long compared to if you had a multi-layer switch. I've got one somewhere close, like a multi-layer switch, physical one. If you power it up, it takes minutes to go just through the power on self-test and then initialize and get going. So we're just a few moments away. It's gonna be totally worth it. Oh, you want to hear a joke that Wendell Odom told me? Yeah, this is a good Wendell Odom joke. He goes, "What's a gateway?" He says, "About 50 pounds." If you have if a gate, how much does the gate weigh? I thought it was pretty good at the time. I'm reaching here for jokes. Keep the day job. Hey, last night, and this is almost ready. Last night I went to a play my wife is in. It's called Men in Boats. It's written about General Powell or Mr. Powell, the explorer in 1869 down the Colorado, and it was fascinating. And so the cast, the way it's written, is played all by women, these 7 or 8 women that play these roles of men. It was so funny. My son was in town. We just had a great time. My stomach hurt. I was laughing so hard. It's a comedy, but it also teaches history about the and they had it was a fairly small theater, maybe seats like 100 people, and it was amazing. Good job. I'm very proud of her. A lot of fun. All right, and I think we are good. Let me bring back this. I need to line it up just so right, and then we'll do all that work again, except not the proxy ARP because we don't need that anymore because we're going to be routing now. All right, so I'm going to line this up so it looks nice and pretty on all of our screens. There we go. Okay, so long story short, core 1, show IP route. Routing is enabled because it's showing us the decodes for all the possible routing sources. If routing was not enabled, we'd simply say, here's the default gateway, and we're good to go. Oh, it's connected. VLAN 1 has a different interface, I think. Let's do a show IP interface brief. Yeah, it's got .11. We have the technology. We can fix that. Let's go with our original scenario. Interface VLAN 1. That's the, gosh darn. All right, take a breath, Keith. Interface VLAN 1. This is the switched virtual interface. And we'll say IP address 10.0.12.111 with the 24-bit mask. Just like that. Now in IPv4, when you write and configure an IPv4 address, it overwrites the previous one unless you do something else tricky, like a secondary address or something. But so we have one IP address. We'll verify that with the do show IP interface brief. And now we'll add ospf to this bad boy, and we'll be good to go. So router, ospf, process ID 1. Router ID, 111.111.111. We go. There we go. Done. Network statement. Network. I'm going to go for all wildcards. 0000. And what that says is, hey, Mr. Router, if you have any IPv4 interfaces that are enabled for IPv4 and up, they're in. Everything's going to match because the wildcard bits say we don't care about matching specifically on anything. All IP addresses are in. And we should have 2 neighbor statements or 2 neighbor adjacencies full in just a moment, and there they are. So router 1, router 2, fully adjacent. And now, where we left off in our last scene with the show IP route, and I'm going to limit this to say, please show me just OSPF learned routes. And that way the routing table will be a little bit smaller. Show IP route OSPF, enter, and here we go. So what we were looking for is the 10.0.1 network, which is right here. And this is in English. Here's what this says. I'm routing for other people. If I get a packet that's destined for 10.0.1, that network that we're looking at right here, I am going to forward that to the next router at 10.0.12.1, which is R1's address. And that I'm going to use the egress or exit interface of interface VLAN 1, which is the only layer 3 interface this switch has to deal with. And then what it would do, a packet being sent there, this switch, this core 1, would encapsulate at layer 2 the layer 2 address of R1, forward it, router 1 would get it, de-encapsulate, look at the destination layer 3 address, and then re-encapsulate layer 2 and continue forwarding in the direction it needs to go to the final destination. So who sees the problem with this? I do. I don't see a default gateway. I don't see a default route in this case. So default gateways are for devices that don't support routing for other people. Now we're doing routing, but I'm looking at this output and I don't see a default route. So how do we add a default route to OSPF? I'm going to show you right now how to do it. And then you'll have that in your arsenal and you'll be good to go. Somebody on this network, somebody needs to add a default route into OSPF. Will it be R2? Will it be R1? Will it be R3? Will it be R4? Somebody needs to do it. And the way we add a default route into OSPF is we use the command, we go to router configuration mode, and we say default information originate. And I think the hyphen is right there. We'll find out in the live interface. So if we go to R1 and we say default information originate, what R1 is going to do, and this is pretty cool. What R1's going to do, R1's going to say, wow, you want me to originate like the origin story for for any Marvel character. You know how they have the origin story of where he came from? That's what this is for, a default route. This is us telling R1 in router configuration mode for OSPF, default information originate, bring in the default route. And so R1 will do it. Now, if R1 has a default route, it will do it. It will inject a default route into OSPF and advertise it so everybody else can use it. But if R1 doesn't have a default route, it won't. R1's like, okay, I get to bring in a default route. But if R1 doesn't have its own default route, it's like lying. Like, why would I tell everybody I have a default route when I don't have one? So we're going to tack on this option called always. So that command right there says to R1 basically this. Mr. R1, look, I know you don't have a default route, a real one, but for the benefit of everybody in the area, to make them feel better, I want you to originate a default route, add it to your routing table, or add it to OSPF, so all the other routers will think they have a default route. And if they need to forward packets and they don't have a more detailed route, they're going to use their default route, which is coming your way. So hopefully you can do something with that. But that's how the default information originate always command works in OSPF. And the good news is we can see it right now because we're going to just go ahead and do it. And that's the best way to practice and learn these things is by actually experiencing them live. Let's do and doing hands-on. You can do this in Packet Tracer, by the way. It also supports this. So back at the interface, we'll do a show IP route OSPF, and just for grins, show IP route, just to verify we don't have a default route from any source. There's no gateway of last resort. Then there's no default route. Default routes are going to show up near the top of the list. These are now sorted numerically. So if you have a route for 0000, it's going to be at the top of the list. So let's go to R1 and we'll add one. Show IP route. So the trick here on R1 is R1 doesn't have a default route, and that's okay. We'll just use the always option and tell them to lie. So config t router OSPF1 and default dash information, originate, meaning I want you to put this in ospf, please, and always do it, meaning, oh yeah, always advertise the default route, whether you have one for real or not. So we'll do that and press enter. And then let's go make a road trip over to our core switch. So ospf is very fast to converge. If we do a show IP ospf, I'm sorry, let's do a show IP route ospf. And then I'll just go and hit another key except for space, just so we don't have to look at all the output there down below. This is coming in as an ospf route. This is the default route here. Here's the syntax. And according to core 1, its next hop is going to be 10.0.12.1. But every router in the area knows about this default route. If we went to router 4 and did a show IP route, it's got it. Right, let me scooch up a little bit. So this is router 4. So it knows about the default route. From our 4's perspective, it's going to use 10.0.24.2, which is R2, as its next hop. But the key is everybody has it. So if we did a ping to 10.67.83.123, which does not exist, what's going to happen is this router is going to look, as this is multi-layer switch, it's going to look at its routing table. And it's going to say, do I know how to get to that? Do I have a route explicitly in my routing table that matches that, or at least the first part of that? The answer is it doesn't. It's got routes for 10.01, 10.02, 10.03, but it does not have a route for 10.67.83. So as a route, as a default, as a fallback, it'll say, oh my gosh, I don't have a more specific route. That's how routers do. They go for the longest specific match first every time. The longest specific match in the routing table, but there's no match. It goes to the Obi-Wan Kenobi route, which we're calling here our default route. And it's simply going to say, we're going to use default route of 10.0.12.1, and that'll be the next hop. That'll be the next router that we're going to forward to. And then here's what the switch says. Not my problem. I forwarded the packet. I'm done. Next packet, please. And then they play that game millions of times a minute as they're forwarding packets across the network. So instead of doing a ping, let's do a trace. So we'll do a trace to 10.0, and we'll also I don't know if DNS lookup is on or not. We'll see. So it's not. So we'll do a trace to 10.67.83.1. The first hop was router 1. And then we have all these messages effectively. These are ICMP messages coming back saying, yeah, I got this packet for 10.67.83.123, and I have no idea where to forward it because I don't really have a default route. Otherwise, I would have used it and forwarded it to somewhere useful. If we wanted to kill those packets, we could put a null route on R1 that just kills everything, which is easy to do, by the way, if we did this. Yeah, another story, another day. I just want to verify that our default route is being seen, and now we've injected it via ospf. All right, let me make sure I look at my notes and cover what we wanted to cover in this session, then we'll go to Q&A after I take a short break for water. I wanted to identify two situations. One is a device that's just routing for itself, and that boils down to it's not willing to take packets from somebody else and make layer 3 routing decisions on it. Devices that behave like that by default would be a layer 2 only switch, an end device like a PC or something else that's not really trained to forward packets on behalf of someone else unless you're running software that allows you to do that. And the other option is, and for those devices, they need a default gateway. So the question yesterday in the queue was, do I need to have a default gateway configured on every multi-layer switch in my enterprise? The answer is, if all your multi-layer switches are doing routing, no, because they can dynamically learn their routes, or they're in the routing table and they can use a default route. You can either put it there statically, or they can use it through a routing protocol I learned to route and forward traffic. If we disable IP routing on a multi-layer switch for version 4 of IP, then we would need, unless you have proxy ARP enabled, then you'd need to enable a default gateway so that that device could forward packets correctly off of its local network. So default gateway, think of a device that doesn't route for other people. And default route, think of a device that does route for other people, but it's a last-ditch effort if it doesn't have a more specific route in its routing table. And that's that's what I wanted to cover in this CCNA Sunday. what I'd like to do is take a quick break, not too long. I will put on some intermission scene for just a few moments, and then I'll come back in less than 30 seconds, and we can wrap it up with any Q&A that you have. Now, as we prepare for that, if you have any questions that are related to what we covered today, that would be ideal. If you have questions that are also related to CCNA, Cisco's 200-301, that level, that would be great. That's what we're going to focus on. And anything that's like way out of scope or a specific scenario that's out of scope, I may pass on those, not because I don't want to answer them, but because I think I want to focus all of our energy here in these streams and this content for people who are working on their CCNA. So if you can, do me a huge favor. You get real close for this. Just ignore the whole part about proxy ARP. Just if you're a CCNA, just pretend it doesn't exist. Doesn't matter. And then when you get into CCNP level and CCIE, come see me and we'll talk about why that works and how it works, even in greater detail. All right. Thanks, everybody. We'll see you back for Q&A in just a few minutes or a few moments.
I've been waiting all my life for someone like you. I would watch the days go by, wasted and blue. I was out of use. Now every day, every night, every moment with you, I'm walking on air. And every day, every way, I feel I can't lose. I wanna shout it out, ain't no limit. I wanna shout it out to the world. You got me all worked up, got me spinning. I'm crazy for love, crazy. Life is a winding road, no telling where it goes. Driving through days and nights, won't stop for traffic lights. And I really wanna know, really wanna know.
All right, welcome back for the Q&A. And for this Q&A, if you have questions that you had earlier that got answered by other people in the forum, fantastic. I am working on the Discord server, watching some great videos on YouTube on how to set that up, how to control it. It's going to be fantastic. I would guess that by next Sunday, I'll have it all dialed in. I've got a few people who have volunteered to moderate. If you want to volunteer to moderate the Discord server, I'm looking for people who are wanting to help other people. And that if you're one of those and you're willing to spend a couple hours a month in Discord and answering questions and moderating, I would like to take the list of everybody who wants to do that and give you that opportunity. So let me type in how to do that. contact@thekeithbarker.com. Yep. So I just chatted in an email address. This is an email box that I don't check. I haven't checked that off in the past. I need to do that more. I'll keep my eye on it for this purpose specifically so that we have some way of communicating. There are a few people in the room right now, which I have very much appreciated their support as far as helping out and doing things. If you do become a moderator, you're going to have direct access to me. So I'm looking for a little friendly team, not like a full-time gig, but just like a team of people that we can kind of build a circle of teamwork and collaboration to help a lot of people. And I can't do it by myself. I can't moderate the whole thing by myself. That's why I'm looking for help. So you'll have access to me. That's one of the small offerings I can give you is that you'll have access to me. So if you have questions or comments or concerns or whatever, I'm super excited about making our content available to tens of thousands of people who are learning CCNA every single month, because those are the numbers, I believe. And the moderator team will help make that difference. So if you haven't subscribed yet, please do so. Send me an email at that link I just supplied if you want to be a volunteer for the moderator, and I'll go through everybody who wants to volunteer. I will take a serious look at. And again, we need all the help we can get. Super. Thanks, Murray. So if you have a question for me, go ahead and do an @KeithBarker in front of it. That way it shows up in bright, beautiful orange for me so I can see it, and I'll be happy to take your questions. I'm looking at this screen right here. This is where the Q&A is. I'll make sure my mic is brought in pretty close, working on improving that all the time. All right, and the first one that I see, I'm going to highlight these as I go through. Paul is asking, on a 3650 switch, why can't I assign an IP address to a switch port? Great question. So if we have a switch port with like 48 ports or 24 ports or how many ports it has, by default they are layer 2 switch ports, meaning they're expecting to be associated with a VLAN. So switch port mode access to tell it it's an access port versus the trunk, and then switch port access VLAN 10 to assign it to VLAN 10. And there's no reason or opportunity to put an IP address on that switch port unless we change the rules and we say, hey, you know, dear gig 1/2, a good joke, by the way, is that's gig 1/2. If you ever hear somebody say that to you and they know what they're talking about, it's just a joke. Hey, that's gig interface gig 1/3. Because it kind of looks like a 1/3. Anyway, if we're in gig 1/3 and we want that interface to be a routed interface, like a Cisco router interface, the command is no switch port. No switch port. And say, well, what does that do? No switch port tells the switch port that, hey, you did a great job, appreciate your service as a switch port, but we want you to act as the layer 3 interface now, the physical interface. And as a result, that physical interface where we said no switch port, it's now like a router interface. IP addresses are now accepted on that interface. If it still doesn't work, where maybe the no switch port command is not supported or you can't put an IP address, you may have a switch with the wrong image. So not all images for iOS on Cisco devices are created equal. If you have a basic IP license or a basic license that only supports switching, maybe that's not going to be an option. But on most layer 3 switches that are current and like enterprise license and so forth, you can do a no switch port IP address and you're good to go. That would be my first guess on why that's not working if it doesn't currently. Okay, next question from Darshan. I thought when you don't have a default gateway, when we get output of unreachable and the router doesn't have a... I'm not sure I completely understand your question, Darshan, but what we saw from the lab was that if we have a multi-layer switch with IP routing disabled and we have a VLAN interface with an IP address and we don't have a default gateway, its behavior by default is to ARP for a non-local address, which normally devices should not be ARPing for some layer 2 address for an IP address that's not in their local subnet. What they should be doing is saying, oh, this isn't the local network, and as a result, I'm just going to go ahead and forward it a layer 2 to my default gateway and have him or her handle it. But here, what we have is I had router 1 and router 2 with proxy ARP enabled, which means if they hear a broadcast, an ARP request, and they have a route to where that corresponding layer 3 address would go, they lie. They do a proxy response of their own layer 2 address. So the switch just said, hey, I got a response and I'm going. So there was what do you call it? A conspiracy, really, because the multi-layer switch without a default gateway and the 2 routers on each side, which both had proxy ARP enabled, the switch was willing to do a broadcast for a non-local address, which is a problem because it made it work, and the routers were able to listen to that and lie with the response coming back. So hopefully that answered part of your question. Let me take a look at the list as we continue on. Give me one moment. Okay, will a DNS request use the default gateway or a default route? So a DNS request, which is where the client says or a device says, hey, I want to go to cbtnuggets.com. What's the layer 3 address for that? That's a DNS request. Clients are going to be configured with a DNS server. So they could have learned that DNS server information from DHCP probably. And here's how it works. If the client says, okay, let's imagine you and I are clients. We're sitting on the network 10.0.1 like we were in the lab. And we get a DNS, we need to make a DNS request. If our DNS server is local, we're going to forward it directly to our DNS server. But most of the time, the DNS server is not going to be on the same subnet we are. So we would forward that as a unicast request at layer 3 to the IP address of the DNS server, and at layer 2 to our default gateway because it's not on the local segment. So DNS requests from a client would go to the default gateway if the DNS server was not on the same local IP network as the client making the request. Great question. And then when the router gets it, a packet destined to the DNS server's address, it would look at its routing table. And if it had a match for the DNS server, like the match could be if we had 8-bit routes or 12-bit routes or 16-bit routes or 27-bit routes, we look for a match from any of our routes based on the destination IP address. And if there's a match, we follow that routing information, the router forwards it. If the router doesn't have a match, it would then go use the default route as a last-ditch effort and use that to forward the packet. So as far as a DNS request, would it use the default gateway or default route? Oh, I just answered a different question. If the switch is not doing IP routing, it would have a default gateway, and it would use this default gateway to forward that request to a non-local DNS server. If the switch was doing routing, it would then use its routing table to make that forwarding decision to the DNS server. So the default gateway on a multi-layer switch is not used at all if IP routing is enabled. So thanks for giving me a second chance to answer that question. That was from Boom Data. So it just depends if IP routing is enabled or not, and if the DNS server is local or not. All right, the Joshy89 is asking, can you help me better understand layer 2 and layer 3 switching? Absolutely. In our playlist, if you start near the top of the master playlist at YouTube, one of the first 2 or 3 videos is about layer 2 switching, and now we're talking about layer 3 routing with IP packets. Those would be great resources to go to. One of the elements that's a little confusing for some is that we're dealing with switching, just raw layer 2 switching. We're forwarding frames based on layer 2 addresses. Just that's the whole game. And with routing, we're looking at layer 3 IP destination addresses, and we're making forwarding decisions based on layer 3 IP address header information. So routers, like traditional routers, are routing packets at layer 3 based on IP addresses. And switches, layer 2 switches, are forwarding frames. This is what we call the data elements at layer 2, a frame of data based on layer 2 addresses, the MAC addresses in those headers. So now what about multi-layer switches? How does that work? A multi-layer switch is a device like the one we had in this lab that can do layer 2 forwarding. So it's memorizing layer 2 addresses, making layer 2 forwarding decisions, but it also has switched virtual interfaces at layer 3. So if we send something to that layer 3 address based on its layer 2 MAC address associated with that, it will look at it and it can make a routing decision or a forwarding decision based at layer 3. So with multi-layer switches, if somebody says layer 3 switching, I totally don't. If it was, if you and I were talking like nitty gritty, never call a thing a packet unless we're talking about layer 3, and never call it a frame unless it's called. People in the real world, outside of academia and outside of studying this, they are going to very loosely talk about switching. Like, yeah, we're going to switch that packet from here all the way to there, even though they may be talking about routing packets. Switching, moving. So unless we're being correct in context, terms are used like that all the time. Or, yeah, the frame is going to take that packet. Or the switch is going to take that packet and forward it. When, really the switch is looking at the frame information at layer 2 and making a forwarding decision if it's a layer 2 switch. So I forgive everybody. I don't call anybody on that unless I was like in a boot camp. You will call this. And the reason it's important is because it's really important to understand how the network really functions. That's my big goal of this whole channel for CCNA people, is that I want CCNA people who are learning networking and CCNAs, is that if you really understand how it works, which is my objective here, to share what I've learned over the years with anybody who will listen and wants to participate, if you really understand, your value goes up. Your value goes up because it's not just memorizing a tidbit or a factoid or something for an exam. It's that these are going to start to come together. And what you'll notice as you continue through these streams and rewatch them is that your knowledge and understanding is better. And people learn differently. Some people visualize, some people are more auditory, some people are more kinesthetic, and but however you learn, whatever your method is, the more you put it all together, when I think of a network, my brain is in a different place. Like when I'm at this is a recording office I have here in Las Vegas, and my house is like 15 minutes away. So when I'm here in this office and something goes wrong, I'm thinking, okay, what does work, what doesn't work, what is likely the problem? And I'm it's just from repetition. I'm thinking about layers in my head, not because I have to answer it on a test, but because I'm thinking, well, the ping works. but the service doesn't work. So I realized that, well, if the ping works, guess what? Routing is solid as a rock. Don't look at routing anymore as far as like how to forward, because the ping works. That's all the way up to layer 3, and it's going back and forth. So there could be something at layer 4. Maybe it's a filter or an access control list or some security thing, or maybe the service is down. Maybe we're going to a web server or some other service like FTP or HTTPS or a streaming server, and maybe the server itself is not responding. So just being able to, can we go to our default gateway? Can I ping my default gateway? Yes. Can I ping to the internet? Yes. Can I use web services outside that? No. And then I would just isolate the fault domain. Well, I don't know how I got on all that. But layer 2 and layer 3 switching, it could be, if somebody says layer 3 switching, I wouldn't cause it. Really what's happening at layer 3, whether you do it in hardware or software, is routing. But I wouldn't stop anybody on the street and say, you can't say that. I want to make sure they understand how it works. All right. Another question. I thought, by the way, thank you for the questions. So good to have you here. I thought when you don't have a default gateway, okay, that was a previous one. Murray's asking, can you create labs in Packet Tracer that require us to troubleshoot problems? You know what? Oh, I'm glad you brought that up, Murray. Thank you. On the Discord server, I'm super excited about setting it up well. But there's a section where we can have people download content, and I think what I would like to, I have like 4 thoughts in my head. Let me go for one of those. On the Discord server, I'm going to make a channel or a category for requests. And I'm going to say, I'm going to have one for CCNA, like requests specific to CCNA, and then requests for everything else. Like, I want to do traffic engineering with MPLS, and I want to do software-defined implementation. Other requests. It's just so I have them all. And then that way, if I take a look at the CCNA-related requests, if there's a lot of them, including we would love some Packet Tracer labs, or we'd like to do troubleshooting scenarios. Can you build us some labs that have known challenges in them to go ahead and troubleshoot, and we can time it, see how long it takes. I will make that forum, that group, so we can put those ideas in. Because I was talking to my son Paul till I think it was like 1 a.m. in the morning last night after the show, having a great time, and we were discussing how to be successful and help other people. And the answer is give them what they're looking for. It's like, I get it. And so what part of my feedback that I got from him was find out the individuals. I'm talking about you. Everybody who's watching this right now. Find out what you want. And if I can deliver that, that's what I should focus on. And in my case, I'm narrowing it to CCNA for YouTube. That's what I want this channel to be. I want it to be the de facto go-to source. If you're studying CCNA along your way, you should check out these videos because they will be very helpful to you in your journey. And so in the Discord channel, what I can do is make that, our Discord server, I can make that channel called requests of things you'd like to have, and then find out and make it easy. So you can just go to Discord, say, yeah, I want this, I like that, and I can find out what everybody wants. And then I can focus on that as opposed to, I think they need to know this. Or there are some things that we need to know. But as we start building this full playlist and making it very, very effective and leaving on the questions now at the end based on your feedback, that'll be a great tool for finding out what you want. And Packet Tracer is certainly one of those that I'll wait till the Discord server's up so I can collect them and not lose them. And if that's something you'd like, troubleshooting labs in Packet Tracer, and then I could present those very quickly. Here's the overview, here's the topology, go! And you can do them on your own time and leave feedback in Discord. I think that's a great idea. So if you would, Murray, when Discord goes up, which will be, my target is next week, add that as a suggestion for CCNA ideas. Thank you. That's awesome. Thanks, Murray. All right. Alex is asking, does enabling proxy ARP have adverse effects in production network traffic? I don't think so, because what it did was it made traffic work that shouldn't have. It's like, hey, the network's magic. It's just forwarding. We don't know how it's working. It's just going, which maybe that's a great thing. So proxy ARP is used more than just in this scenario. Proxy ARP is also going to be used for when we have certain NAT implementations where it's going to be an important feature to have. So it's on by default. I didn't change these, so it's on by default for these devices. I don't recall off the top of my head of proxy ARP having a negative impact, other than if you're doing a live stream and you're trying to demonstrate the need for a default gateway, and then that freaking ping works, even though it shouldn't. That would be the negative impact for a live stream. Oh, and Pomeroy is saying, I passed CCNA today. Fantastic. It is for record keeping, this is the 23rd of February, last possible day to test on CCNA. Way to go. Way to go. Oh, and Van Ray's asking, what would be the qualifications for a moderator? Great question. Thank you for that. If you want to help other people and just put in a little bit, I'm not asking for any kind of like a job commitment. I just want somebody who would be able to check occasionally. The moderators will have in my mind, we'll see how this rolls out. The moderators would have the ability to identify, if there's harmful or mean speech that's happening. We're going to clamp down on that. They would be able to recognize that and put that on hold. Just that you see it, and also possibly ban other people from the site for repeated offenses. I don't want anybody accidentally to get booted, but I do want if a person is just going to be mean and they don't want to help. I got bullied as a kid. Wow, we're not talking about that today. So anyway, I just don't like bullies of any sort. So if you want to participate and just help, like you don't have to know the answers to all the questions, but if you have internet connectivity and you want to help the community, and you're nice, you have a nice public disposition, you're nice to people, and that's really the qualifications. Wow, talk about bullying, not good. When I grew up, I was 16, I was 82 pounds, and I was just small. I was 5 feet tall. My first driver's license in California, Camarillo, California, where I grew up. I should have kept a copy of it, but my first driver's license when I was 16 showed me as 82 pounds, 5 feet tall. Try to get a date that way. Nah, not happening. Yep. So anyway, thanks for that. Paul, great. Thank you for that. And let me see if there's anything else here. I appreciate all the feedback people are giving other people. That's fantastic. Oh, and Trust the Process is in the house. I see him. I see Trust the Process answering questions. Trust the Process, if you would be willing to be a moderator, I would love that. And by the way, I'll give all the moderators, if you don't already have it, the OG of IT themed t-shirt. I've got a few left, and I'll hook you guys up. So you'll get accolades from me verbally, you'll have access to me, and my thanks for helping out the team. Okay, thank you, Murray. A few moments of stutter. So I changed a few settings before the last live stream. I have the new camera, and I thought to myself, should I change those things back on this one? And Paul, my son, said, you might want to change like one thing at a time. Don't change 2 or 3 things. So I appreciate that, and I will continue to dial in to avoid the stutter. Okay, so Raphael is asking, cool, how can I join the Discord channel? Once it's ready, I will send invites as moderators. I'll send invites to those people who want to be moderators, get them dialed in, and then in a live stream, I will give an invite link where you just click it, and it'll take you right there. You can join with that invitation and become part of the channel, become part of the party. Michael's asking, can you give us homework? Yes. And Michael, if you would, let's put that in the recommendations in Discord so I don't lose it. And then I can just take all those recommendations and sort through them and do it. So I'd be happy to do homework. Yep. If you'll do the homework, I'm happy to assign it. And Michael's saying proxy ARP also allows frame relay to work. Fantastic. Looking through, looking for my name to see up front if there's any other questions. Thank you for the kind words, everybody. Okay, Ashish, I hope I'm pronouncing that correct. A-S-H-I-S. Good to have you here. Oh, can you explain gratuitous ARP, please? Let's talk about ARP for a moment. So we know that ARP is a process where if we're a PC or a network device and we need to forward a frame to another device on that same local network, by default, if we don't have that in our ARP cache, we'll send an ARP request. The ARP request is shouting, hey, I'm looking for my default gateway, which is IP address 10.0.1.1. I need the layer 2 address on your network interface card so I can forward frames to you in the future. We shout that to the room. It's sent as a broadcast. So the switch is going to forward that to every other port in that VLAN. And that could be across multiple switches with trunking. It goes everywhere in that VLAN. And then the person who has that IP address, 10.0.1.1, if that's the IP address we're looking for the layer 2 address, would hear it and say, oh, that's me. And it would respond with its layer 2 address back. Now, there isn't 2 ARPs back and forth. What happens is if we do an ARP request, we include in that our layer 2 information. So when the router gets that, it says, oh, well, here's your layer 2 information. I'll put that in my ARP cache. and then it does the ARP response. So it's a request and response, and then both parties have the layer 2 addresses of the other one respectively with just those 2 packets back and forth. So that's a normal ARP request. What would happen if we go to a restaurant or we go to some event and we have a really great time? It's very typical in many areas of the world to tip, leave a gratuity. They call it a gratuity. It's not required. It's just kind of, offered. And a gratuitous ARP is an ARP response or an ARP message that no one asked for. It was out of the blue. It's an ARP response out of the blue, meaning it wasn't requested by somebody. So you might have a router. If it does a gratuitous ARP, it's somebody saying, boom, here's my layer 3 address, here's my layer 2 address. Anybody who needs that, you now have it. Now, is it a little dangerous? Could be, because if you have a hacker, right, who's lying, he could be doing gratuitous ARPs, corrupting the layer 2 ARP caches on devices and becoming a man in the middle. That's why we should use security measures like dynamic ARP inspection to verify that. But that's what a gratuitous ARP is. It's an ARP message that's being sent free of charge, like as a gift, not being requested by anybody, but out of space, just out of the desire to do it. And there's reasons to do it. If we're cleaning up ARP caches or we have changes in the network, we might issue a gratuitous ARP just to verify that everybody has the latest information. So hopefully that helps. And another question. It's EIGRP, and regarding the router ID for EIGRP. Now, in Cisco CCNA, the current one, there's no EIGRP at all. So I probably won't include that as a live stream, but for questions like that on the Discord server, like CCNA related topics, and then we'll have other. Go ahead and offer that in the other category, and that way I can not lose it and go through it. And if I need to research something, I can. I haven't played with EIGRP in quite a while, maybe a year or two, but I'm about to because I just finished ospf, and I'm going to touch on EIGRP for the NP level. So I have to revisit it, the K values and the metrics and the feasible distance and the feasible successor and relearn how all that works, except this time it'll be a lot. It's always faster. After you learn something 6 or 7 times, you hit it again the 8th time after, it's like, oh, yeah, I got it. So put that in a request on Discord, and I will take a look at it just because it's beyond the CCNA level. Bashkar is asking, Keith, could you please briefly explain TCP flags? Flags are simply just bits that are on or off. And so in a TCP header, there's flags for what type of message is this? Is this a TCP? So when 2 devices want to connect to each other with TCP, think of it like going to here in the States, if we go to a grocery store, or here in Las Vegas, if we go to a grocery store and we just walk up to somebody, like another customer who's looking at the vegetables, and we ask them, without making eye contact, we ask them, hey, do you know where the rutabagas are? Here's what I think the default response would be. The default response, I think, would be, I hope they're not talking to me. No eye contact. And I'm just going to ignore that and see if they go away. And that's kind of like how UDP operates. It doesn't care about establishing a relationship before they start communicating. So if we took that same scenario with the shopping center and the grocery aisle, and if we were TCP, it'd be like us going up and getting eye contact and saying, hey, how you doing? And then they look over and say, fine. And we say, great, good, nice day. Now, that little exchange, that 3-way handshake, confirms that we are talking to each other. There's no doubt about it. We know they can speak the language, at least those words, because we had that communication. And then we could ask them, do you know where the rutabagas are? Whether they do or not is another story, but the 3-way handshake, that little conversation, syncs us up and gets us moving. So in TCP, they do that. There's a 3-way handshake, and the flags in the TCP header help to indicate, there's lots of flags actually, but part of the flags regarding the TCP conversation indicate, is this a synchronization request? Yes or no. And that the initial 3-way handshake is a synchronization request. And then the response back, it has flags that say whether it's a synchronization request or if it's an acknowledgement. And the response back has 2 flags that are set, the acknowledgement and the synchronization. So 2 for 1. So the server says, or the client says, TCP SYN request in the header. The response coming back from the server is acknowledgement, flag bit, and then also my own synchronization request. And then the third and final one is the final acknowledgement from the client. So those flags help to identify to the receiving parties, among other things, what type of TCP segment this is. So officially at layer 4, we call the datagrams, the chunks of data with their headers, segments of data. And at layer 3, we refer to them as packets of data with the IP header information. And then that gets encapsulated further into frames of data with the layer 2 information added. And those headers just keep making the data bigger and bigger and bigger. So hopefully that helps a little bit with some of the TCP flags in the TCP header. Okay. Oladeji, I pronounced that probably wrong. Oladeji. I'm glad you're here. Asking, are you the one taking MPLS in the CCNP Encore? Good question. I know Jeremy's doing the BGP. I think I am doing MPLS. I think it's in the ANSRI course as opposed to Encore though. But regarding MPLS, I believe I am the guy doing that because I love it. I love MPLS. I love explaining MPLS switching and labels and popping and pushing and all that good stuff. So to confirm, I believe I am the person who's doing it in both the Encore and then the concentration exam following that related to Enterprise for CCNP. And what happens is, as a team at CBC Nuggets, we chat and we discuss, okay, who would be the best at this and who has time for that. So I believe I am doing both of those. Thanks for the question. And if I'm not, it'll be somebody amazing, but I believe it's me. All right, trust the process. Thank you very much for all the feedback and help in the channel. It's amazing. I'm grateful. And Almighty Mech is saying, yep, there's no EIGRP. It's crazy. They're saving that. There's some in CCNP level. All right, moving on. Just taking a look at these questions here. How fast do you think it's possible to get the CCNA? This is coming from Jorge. How fast do you think it's possible to get the CCNA, and what would be a good strategy to achieve it? I'm a starter. Thank you so much for doing this. It really depends on your knowledge and your willingness. I was able to get a CCIE in 8 months, and that was studying like 4 hours a day, 4 or 5 days a week, which was totally worth it, by the way. And for a CCNA, people take tests differently. I would say, how long would it take for somebody to take the whole blueprint, go through it, make sure they're comfortable, do it hands-on, and probably for an average learner who's committed to a few hours, I would say 3 months. If somebody was going to schedule the time, talk to their loved ones and say, listen, I'm blocking off this chunk of time. It's important for my career. I need to get the certification. I enjoy the technology. Keith Barker thinks I can do it, which I do, by the way. And then schedule that time and do it. And if you schedule the time religiously, meaning not just on Sundays, but or Saturdays or whatever that religious day is for you, but schedule it and then do it. And then when you're doing it, turn off social media. That's my father calling right there, Bob Barker. I'm going to have to say sorry. But if you're studying during that time, turn off all your social media, turn off your email, have a plan on what you're going to study that day, study it, set a limit. Also, I would say don't study for more than 2 hours at a time because that's, well, I can't say that always because I've done that before. But if you set moderate study times and you enjoy it, and then you have a plan for what you're going to study tomorrow, I think a person in 3 months with a good book, with some videos, and from any source that works for you that's fairly entertaining and also useful, I think 3 months would be a fair target. And Packet Tracer is free, so you have hands-on access there no matter where you study. So I think 3 months would be realistic. I would try to not push it. I think my big change for me when I got my first CCNA, when I got the CCNA for the first time, was I was pushing it too hard and not really enjoying it. I was like memorizing. Enjoy it. Enjoy the knowledge and learn it to know it, and then share it with others, teach others, help others. And this is a great way for me. This live stream is a great way to refresh all this information in my head as well, and then pass it on to others for as long as YouTube is in business. All right. Got a question from Dino about multiple ISPs, multiple default routes, load balancing, HA. So those questions are great. Beyond CCNA though, so in Discord I'll have 2 sections, one for CCNA related, one for others, and then if you could put that in the other, that'd be fantastic. And then if we have time to look at it or get to it, I will make attempts at addressing many of those. Great feedback from a lot of people. Ashish, dampening with BGP, same thing as far as way beyond CCNA. But again, on the Discord server, I'll have another channel for other things, and if you want to add that there, I'd be happy to take a look. All right, Darshan, thank you. Mohammed's asking, hi Keith, how to keep up to date as my day-to-day activities, not dealing with all the technologies and dealing with mixed environments, Juniper, and other vendors. It's it's tricky. I had a lot in my career, and currently I work with a lot of different vendors and topologies and technologies. Checkpoint, Palo Alto, HP, Cisco for sure, VMware. I do a lot of work in the cloud. I'm not an expert on cloud. We have some experts at CBT that do that. So I think the key is focus on what you want to focus on. And then if there's a certification track that kind of provides a structure, that's a great way to go. Follow that structure and enjoy the process, enjoy the journey. But keeping really up to date on everything is something that I'm not able to do myself. So I'm not the best person to give you feedback on that because things do fade. I remember teaching something. Oh, this is a true story. I teach a lot of content at CBT Nuggets over the years. I've been there almost 8 years. I started in 2012 and I had a lot of fun being there and work with a lot of great people too. And sometimes if I'm teaching something like, I need to refresh on all that, I'll go back to my content from 3 or 4 years ago and watch it. Like, oh, this is a self-documenting video. It's for me. And I think the same thing is for these streams too, is if they're on YouTube for a couple of years or 2 or 3 years and I need to revisit something like load balancing with spanning tree, I could think, oh yeah, I've got content on that. I'll just go take a quick peek and, oh yeah, that's how it works. Although load balancing with spanning tree is pretty straightforward. But some other topic that I might need to dig into. All right, let's take a look. And I'm scrolling down the list here. All right, Michael's asking, hey Michael, he's asking, can you give your take on the differences between SVI, which is a switched virtual interface? Let's pause there for a moment. So you're on a multi-layer switch or on a switch that has a logical layer 3 interface VLAN 20, or whatever the logical layer 3 interface is that we're going to send address to. What's the difference between that and no switch port on an interface? So every switch from Cisco, every managed switch, has the ability to create a switched virtual interface, give it an IP address, maybe a default gateway if it's not doing routing, so you can manage it remotely. Let me grab a layer 3 switch. Hold on a second. Say hello to my little friend. So this is a multi-layer switch. So let's imagine port 24 right there. So port 24 is normally, on a good day, just a layer 2 port. So internally, if we did a switched virtual interface, it doesn't physically exist anywhere here. It's nowhere. It's logical inside the switch. So if we have VLAN 10, for example, and we go to the configuration, we say interface VLAN 10, and then give it an IP address, there's no physical representation of that anywhere. It's just logical in here. But customers who are in VLAN 10, they appreciate it because they can use that as a default gateway. And then the switch, in its guts, can go ahead and logically route based on that layer 3 address it has and other layer 3 interfaces it may have. Now, this port right here, 24, port 24, it is a access port, or it could be a trunk or an access port, but it's a layer 2 port in either case. If we went into interface config for that specific port and we said no switch port and pressed enter, that port, this one physical port, is just like a physical router interface. It's no longer a switch port, doesn't know anything about VLANs or trunking or any of that stuff. It is a layer 3 interface. So at that point, you could treat this as if this whole box is a router, and that one physical interface is a physical Ethernet, or in this case, gigabit Ethernet port on that router. Then we could take this device with an RJ45 connector, plug it into another switch, And it would be as if we had a router port that was connected to the switch. Or we could connect it to another device with the right cable, and we'd be good to go. So on this interface, we'd give it an IP address, and that interface would belong to this physical IP address. So think of a no switch port as a physical interface router, a physical router interface on the box. That's what the difference is. There's not a lot of, the moment I say there's not a big use case for that, we could probably create some in our minds, but that's how it works. So sometimes when people build a lab, they'll get like 2 or 3 multi-layer switches, and then they'll assign a few ports as router ports so they can think of those as physical router interfaces and they connect them together. So whether you logically use trunks and create logical VLAN interfaces, or you carve out some ports and you physically have layer 3 interfaces, there's a lot of different ways to build these Tinker Toys. So Michael, hopefully that answered your question. Thank you for that. Paul's asking about my CCNA experience in the lab. How was it? It was brutal. I've got a video. I'll save that for the video. If you on my channel, if you do a search for Keith Barker CCNA, I don't know if it's in a specific playlist, but I spent like 20 minutes talking about the experience when I did it. Back in my day when I took the CCNA. It was a 2-day exam, and it was brutal. It was brutal and worth it. It was worth it. I spent 8 months preparing, me and Ed Yanez. I'm CCNA 6783. Ed is 6784. We both took it. We both passed on the first day, and it was only because lots and lots of trying and practicing hands-on. And Ed was my salvation. I saved that whole story, most of that, for the YouTube video. So check that out. It's a fun one. I have a lot of fun teaching it. Also, as you go back in time with my videos, you're going to notice that, wow, look at this. This is the Keith Barker from 2009. This is the Keith Barker from 2019. This is the Keith Barker from 2020. This guy's upping his game. Yes, I am. I'm doing my best, step by step. I'm very motivated by Chuck Keith, actually. I look at Chuck Keith. He puts so much time and attention into the detail, and I just have utmost respect for him. So I've been on YouTube for like almost, I guess, over 10 years now, and I learn from what I see, and I think I can do better. As long as I'm breathing and I can learn, I can do better, and that's my goal. I share that enthusiasm with you in your certification careers and your IT careers. All right, let's see here. Andy's asking, do you think that the new CCNA will miss some knowledge about networking of the... So, do you think the new CCNA will miss some knowledge about networking of the old one? I think the new one is really tight, meaning I'm very happy about the new blueprint. Haven't seen the exam. It comes out tomorrow, the 24th. Yep. But the blueprint looks really good. And what Cisco is attempting to do is they want to have you focus on the skills that you would really use in production, and that you could take this knowledge and then move it forward to CCNP and then on to IE if you want. But the new one, I don't think they're leaving off a whole bunch. I mean, it's got some wireless fundamentals there. It's got really good, solid routing fundamentals. It doesn't have EIGRP, but that's not that big of a deal because ospf is the major routing protocol most people are using for IGPs, interior gateway protocols. So I don't think we're missing out on a whole lot. I'm excited about the new one. It's going to be great. Adolf was saying, I wasn't aware there was a live stream today. I didn't get the notification. If it's YouTube, I just happened to stumble upon the channel and see you were live. I'm glad you're here. I normally will send out notifications on social media the day before, and I had a really interesting, great day yesterday. So after the live stream yesterday, I had lunch with my daughter, then I went out to dinner with my son, then to a show, and I didn't actually post until this morning, like an hour before, about the topics. So it could have been just me. So I apologize about the delay on that, but this will be online in about an hour after we finish. Keith, you've got to finish before you go online. We'll finish here shortly. So Adolf, I'm glad you're here. Thank you for being here. And MIM, I appreciate your comment earlier about the music. I mixed it up a little bit based on your feedback. In a corporate network, do we put a firewall or router first? Which device do we assign WAN link and why? Ideally, before we have the outside world hit our networks, we'd want a firewall, something that's purpose-built to defend the network and application layer inspection and so forth. If we're just going between two of our sites, maybe we're hiring a bandwidth MPLS layer 3 VPN or a circuit that our service provider is providing for us, and it goes from like our headquarters to our branch office, it's very possible we don't need a firewall between that because it's all trusted traffic. But anytime, if it's possible, between the outside world and our stuff, our firewall, our web servers and our public services, it's always great to have a physical hardware appliance because it can handle the load and the analysis of the traffic and maybe doing IDS or IPS as well. So ideally, whenever you're facing the outside untrusted world, you'd want to have a firewall first, then the router. And if there's a perimeter router, that could be okay too. Maybe you don't care about the perimeter router too much. There's not too much going on it. Maybe it's, if you need it for routing capabilities, but most firewalls have the ability to do routing as well. And so we could probably just lump them into one firewall on the outside. That would be preferred. Okay, let me find my place again. I'm looking for the highlighted yellows at Keith. Murray's asking, why do we have routers and layer 3 switches considered that layer 3 switches? Yeah, great. So here's the scoop about layer 3 switches and layer 3 routers. Same thing, except one is done in hardware. And that's it. So whether Cisco uses ASICs like a multi-layer switch for faster processing, layer 3 routing is layer 3 routing is layer 3 routing. And if they do it in hardware and they want to call it switching or they want to call it a multi-layer switch, that's great. But at the end of the day, it's routing. And that's good though, because we can learn routing and then however it wants to be implemented, whether they're doing hardware with ASICs to make it faster or not, it's still routing. So give me a marketing guy right now and I'll just sit down with him and he can talk about, oh, this multi-layer switch and we do fast switching at layer 3 with ASICs. I'm going to say, well, I already own your product. I'm already a fan. It's routing at layer 3. It's routing. It's routing. Oh, and it's routing, whether they're doing it in hardware or not. So some of that's just marketing, and that's good to know. So we can play, and we might work for Cisco or another vendor, and we're a pre-sales support engineer helping customers, potential customers, identify what they need, why they need it, and if the salesperson wants to call it layer 3 switching, great. We'll adopt that lingo, but we'll know in our heads, yeah, we're doing routing based on IP packets, and it's happening very, very fast because of dedicated hardware called ASICs. That's application-specific integrated circuits. All right. Wendy, great. Glad to have you here. Oh, and Dan has a question I think I missed. How do we connect to two different networks at different geographical locations? Use some kind of a WAN service provider. And today we use a lot of service. So you could tunnel over the internet if you want to connect two sites together with the IPsec tunnel, or you could have a service provider who has connectivity to those geographic remote locations and purchase bandwidth from them. In the old days, we used leased lines like 30 years ago, and then we migrated to frame relay, and now we use service provider interfaces most of the time with just, they give you an Ethernet port and say, plug in. Okay, great. And then it's just like another Ethernet network that ends up through the service provider network at the far side. So there's layer 2 options there. There's layer 3 options. We can pair with the service provider. But if you have a geographical separate locations, you need somebody in the middle. So if you want to overlay your connectivity over the internet, you can. There's quality of service issues there with guaranteeing jitter and delay and so forth. Or you have a service provider you pay for the connectivity. All right, Michael, I don't know if I know the answer to your question, and I apologize for not having in-depth knowledge of which is the most commonly seen. People who would know that would be Ben Finkel, who has a social presence, and also Knox Hutchinson. His website or his YouTube channel is Data Knox. He's all things automation, all things APIs, so I'd refer you to him for that one. And Rodrigo is asking, after I pass my CCNA, is following the automation path the way to go for DevNet? To make it rain. We'll see how DevNet goes. I think network automation is definitely happening in the future. Do you want to be a programmer, a network automation specialist? It's important to start with the fundamentals of how the network works so that when you're automating switches and routers and so forth, you know what it is they do. We'll see. If you like my son, I was talking to him last night. He's an amazing programmer, understands databases and interfaces and APIs and working with a bunch of things that I don't have expertise with, but he doesn't know everything. It's like he has certain programming language that he uses for work and that he's a master of, and then others that he's like, yeah, I don't know that. I could learn it, but I don't know it as an expert. So As far as the automation path, I would say what's interesting to you, take a sample of DevNet and some of the training there, see if it rings, see if it gels with you or jives with you. And if it's fascinating, go for it. Start learning, start studying, and then use the certification, the blueprint, as a guideline, a structure to study, and then proceed. But if a person is never going to do network automation, you're in a part of the world or a part of the country where you don't want to move, and you're going to be doing, you don't want to work remotely, and you're going to be working with fairly small networks, it's very likely that you'll never see those automation pieces. With, you go in to support a company, they've got a few routers from different vendors, they're a few years old, and it's going to be basically the nuts and bolts of networking. So it depends on where you're at and where you want to go with it. It does take a little bit of time to study and learn. All right. Adolf is asking, since layer 3 switches are capable of routing, do we still need dedicated routers these days for routing? Yeah, no. So if you go to a data center, it's not likely that we're going to see a dedicated rack-mounted device just as a router. Now, unless it's integrated services and they've got voice service and everything else in there and a call manager integrated. So many times we're going to have multi-layer switches for high-speed multi-layer switches with dedicated hardware doing the layer 2 forwarding, layer 3 routing, and as we have cables that go up to the wiring closets and all the other floors and locations, those will be access layer switches, probably just layer 2, that provide the connectivity through patch panels across the floor to the devices. As we go more and more wireless, we're going to have a lot of access points that can plug into those access switches as well that allow people wireless connectivity. So logically, on a topology, we might draw routers out, but most of the time, those are going to be implemented in a single box without a separate device for the router. But for learning purposes, it's nice and handy to draw a router logically instead of having 5 multi-layer switches and then say, oh, we're going to popping in the VLAN interfaces, which we've done in a couple of our streams, but we worked up to it. I didn't start that with our lead. We started off with basic routing, hockey pucks, the routers, and then as we started learning about switch virtual interfaces, using those as logical routing points, and then routing between them. In this lab, we just took Core 1, and we actually added ospf to it, and we made it part of the ospf routing domain. All right. And I'm just looking for my name. Oh, R. Rios is asking, Keith, did you see the CCNA lab battle between Network Chuck and Jeremy? If so, what I think? Yeah, I loved it. I was in the chats with, I loved it. Network Chuck and Jeremy, both of who are fantastic trainers and I love working with, they did a joint live stream on Network Chuck's channel, and it was like virtual versus physical, and it was great. They're both on the same sheet of music, by the way. Well, they're both on the same sheet of music about learning. Like, hey, let's take the barriers to learning and getting really good and remove them if possible. And Jeremy's point, I'm paraphrasing, is that having that physical access and plugging it in is going to help you figure out the ports and get that really good foundation, which I see the point in that. That's how I grew up. Some people like the Bronze Age. I joke. Today, there's so much less friction for virtual. Packet tracer being a perfect example. If you want, it doesn't take any extra hardware. It doesn't take power. You don't have to deal with the noise. You don't have to get the physical gear that's like vegetables or fruit. After a while, it becomes less and less valuable. And so I'm a big fan of virtual. Although this gear, which I've had for many years, most of it, it does come in useful for a few corner cases. So I see both their parts, and it was fun. It was so fun to watch them together. I loved it. Yep. So I think I did a few super chats for him just to let him know I was there and say hi and let him know I loved him. Okay. Mariano, thanks for that. And everybody else with the kind words and comments. Thanks for being here, too. We still have 150 people. In the United States, we have this thing called a filibuster, where somebody just talks and they take up all the time, so other things can't pass. This is not a filibuster. I'm taking these questions because I want to be here. You're welcome. Okay, is NTP an important subject? And the answer for that, Jamie, is network time protocol is on the blueprint, so it's important to understand how it works, how to configure it, but there's not a lot to it. So there's not a lot of heavy lifting with network time protocol other than knowing what a client is, a server is, and realizing that sometimes it takes 15 minutes to sync up. which in a CCIA lab is difficult. In a CCNA environment, they're not going to ask you about how long it's going to take to sync up or make you wait that long if they give you a simulation. And Ashish is asking, why are you doing a full-time job in a company? If which company are you full-time? So in my career, I started off in 1985. I went to technical school. It was a year-long course, and I went for 8 months. Like, well, why didn't you finish? They pulled me out and said, you're ready. And so the EDS, Electronic Data Systems, which is a company started by Ross Perot a long, long, long time ago, they were looking for entry-level technicians, and so I interviewed with them, and they said, we want to hire you. And I said, I think I've learned everything I need to learn from school. Let me go and go to the field. So I started off as a technician for EDS in Southern California. Loved it, and just kept on learning. And I changed jobs every couple of 3 years as I kept on progressing and getting more skills. And I was always about learning. I worked at Paramount Pictures and Blue Cross of California and other really amazing companies. And so in 2012, I was approached by CBT Nuggets, and I fell in love with the culture. I fell in love with the people. We were fairly small back then, maybe 80 people, 70 people, and now we have a lot of people, including a lot of developers. And I've been there, the longest job I've ever had. Now, the opportunity I have is I still keep my hands dirty in the tech. So it's not just creating training. And a big part of that, too, is when I'm teaching something, I'll build a lab, whether it's virtual or otherwise. I'll build a pretty intensive lab and really go through it. And then because I have that practice, it keeps me a little bit. So I don't take a lot of consulting jobs anymore. I did for a while. I was at, I can't tell you where in Nevada, but I did a project in Nevada. I used to have a top secret clearance, which I don't anymore. So I don't have any access. Don't blackmail me for anything. And also, if you have a top secret clearance, it's need to know basis. And it turns out I don't need to know very much. They would ask me to come in and work on their firewalls in a certain area. Long story short, I had a task. I went in, configured it. I left. I know nothing about what was behind that firewall. I just knew that what they wanted to implement as far as policies. So occasionally I took consulting jobs. Nowadays with the YouTube, which I love chatting with you. I love building these relationships, and I've met many of you. I shouldn't say many. I met a handful of you. If you ever come to Vegas, make sure you let me know so we can say hi. Gus is one of those as an example. I just love meeting people and hanging out. And so going back to the consulting part, most of my time these days is creating content for CBT Nuggets, which I very much enjoy, creating these live streams, which I very much enjoy. And at some point, I also want to create videos that are not live streams, although it's so effective. So for me, it may not be the most polished. Well, it's actually getting better and better. But if I created a video that's an hour long or half hour long, it might take 5 or 6 hours to edit that and get it ready. With a live stream, here I am. So I prepare my content. I go through the lab a time or two, make sure I'm clear on what I want to communicate and what we want to share in this time together. And then I record it. And then when I hit done, it's pretty much done. I don't have to spend hours editing. And then I can go and prepare for my next live stream and my other CBT Nuggets content I'm making. So my full-time gig these days is CBT Nuggets. All right. SD-WAN and MPLS is a question. MPLS is multi-protocol label switching. It's just a transport mechanism to move. So that's where we take a packet and we actually do insert layer 2.5 and a little MPLS header between the IP header and the layer 2 header for the Ethernet. And with an MPLS path, a label switching path across the network, we can then do all kinds of really cool games with it. You can tunnel almost anything you want over this layer 2 path, IPv4, IPv6, routing for multicast. A lot of options. Traffic engineering is also capable. So with SD-WAN, software-defined WAN, what if we rain down those configurations regarding the MPLS network and what we wanted to have happen, and we rain down the configurations with software from a controller? Ta-da! Software-defined wide area network, because we didn't have to go to every device and manually configure it. We just rained it down from a controller. So that's a high-level overview. And it would also go a lot faster if we did it that way too. Okay, scrolling down a little bit. If you need to bolt, feel free. It's been great having you. And then Murray's asking about full duplex wireless. Wireless with, let I'm not aware of full duplex wireless. So it's, yeah, these airwaves, these frequencies. So with Wi-Fi 6, I mean, there's some serious throughput, but I think unless we use two different channels, one for sending, one for receiving, two different frequencies, we still have just a constrained airwave. So if we're using the same small range of frequencies, I don't believe we can get full duplex unless we use two distinct and separate channels, one for sending and one for receiving. But I'm not up to speed on that. All right. A question about when do we see videos on CCNP security. I probably won't do those on YouTube. My YouTube channel here is going to be focused primarily. I want to make sure this is really a clear path for anybody working on their CCNAs. Like, hey, you know, if you're working on CCNA, give Keith Barker's videos free on YouTube a look, and it'll be a good help and enforcement of concepts that you're learning with CCNA. But for CCNP, I probably am going to keep focused here in this, and my Discord server and everything on YouTube. This is my plan at the CCNA level. I want to help those people who are just starting, and anybody who wants to come back to our channel, like alumni, and help them. I would like you to be moderators and help with the process as well. So please don't expect too many videos on CCNP on YouTube. Those will, behind the CBT Nuggets, we have a bunch of offerings there, but not on YouTube. Let's see, anything else? I think we're nearing the end of this list. I'm looking for my name. Thanks for the kind words, everybody. What does CBT stand for, as Kenny asks? Many years ago, like CBT Nuggets was founded like 1999, about 20 years and a few months ago. And at that time, computers were fairly new and upcoming, and let me modify that for a moment. And so a new way of training was introduced called computer-based training, CBT. And so back 20 years ago, it was a like state-of-the-art thing, and the owner of the company, who's still with us, at some point he figured out how to do training and put it on a CD, this new thing called a CD, a compact disc, and then mail those, this is before DVDs, and mail those out to subscribers and sell them on various platforms. I think eBay was probably one of them that I would, if it was out there then. So anyway, that's how we did it. And it grew into, okay, now how do we stream this or get it live out there, and how do we continue to grow? And we're doing very well. We have a lot of happy customers. And so CBT stands for computer-based training, and then the Nuggets part is our training is intended at CBT Nuggets to be concise and nice, ingestible chunks, like nuggets of gold that you can consume that aren't like 2 hours long like this live stream. So in the live stream, I'm loving the questions, and I'm happy to sit. But in CBT Nuggets, our goal is to keep them very tight. So if you come in and you're looking for CBT Nuggets, a video on ospf, there's going to be one on router ID. You click on it, maybe it's 5 to 7 minutes, got a lab to support it, talking about, hey, router IDs, you got to have them, here's how they work. It's going to use the router ID configured first. If that doesn't exist, highest IP address on a loopback. If that doesn't exist, highest IP address on an interface. And that's going to be the router ID. Let's verify that, lab it up, configure it 3 ways, verify the results. I hope this has been informative for you, and I'd like to thank you for viewing. That's our tagline at the very end. And they're intended to be short. Now, sometimes they may need to go, if it's a lab, it may need to go a little longer. That's cool. We give the instructors the trust of saying, hey, if this needs to be 12 minutes, make it 12 minutes. If it can be done in 5 minutes, concisely and with lab support where it's appropriate, fine, make it shorter. And so it depends on the topic and how we want to slice it up. So CBT Nuggets, computer-based training, nuggets of goodness. That's where the name comes from. Thanks for the question. And all right, let me all right, regarding CCI Enterprise, I'm going to leave those for a Discord section on the Discord server once it's up, so you can post those if you want. That way other people can help and answer those. In this live stream, I'm going to focus on CCNA mostly. So thanks for the questions, the comments. I have a couple that are... Oh, the black nail. Okay, so... So thanks, Mariano. So that black nail. My sister, whose name is Susan, she's my older sister. She's 7 years older than I am. She was out. My wife performs at Cirque du Soleil. She's in the circus. She's a singer at O. She sings 2 nights a week on Wednesday and Thursday at Cirque du Soleil. They have one lead singer, and she does it. She did it at Mystère for a decade or more, and now she's at O. They called her in, and she said she semi-retired in 2017, and they called her back in and said, hey, will you come and work at O for a couple of days a week? And she said yes. So that has nothing to do with this finger. So on this finger, there's a little bit of a 2 left from our Subnet Saturday yesterday. My focus is not working. Anyway, so my sister was coming to town. She was coming in. I was going to the airport to pick her up. I was in a rush. I had my hand on the frame of the door, and I wasn't paying attention. And my door that goes to my garage has a spring that pulls it shut, like a hinge spring. And these 2 fingers were in that path, and the full weight of the door just slammed. And I was on my way to pick her up at the airport. And I was like, please, I'm not sure who I was talking to, but please let this stop hurting. It was just like out of control pain. And I just drove to the airport, picked her up, and then I might lose that nail. That could happen. But that's the story on that. That happened about 3 or 4, maybe a month ago, maybe a month and a half ago. So that's the story on the nail. It doesn't hurt anymore. And after about a day and a half, it was still throbbing, but didn't hurt. And now I can type again, which is handy. Okay. And yeah, Cirque du Soleil is a lot of fun. Thanks. Well, I think that's all the questions that have my name on them. I see a lot of people responding and helping other people, so that's amazing. I love networking. I do, and I really appreciate all your participation. We have 154 people live in the room right now based on that screen, and I'm grateful for all of you. Thanks for hanging out. And I'll get Discord server up next week. Think about what you'd like to see, what you'd like to have, and I will do my best regarding CCNA related stuff. I'll do my best to actually create those as live streams or videos, whatever works out most convenient for us, whatever we decide to do, and post them. And that way you can have your opinion, which I appreciate, and I can help deliver on this channel what you want to see. So for everybody who's just joining us late, or if you're not yet subscribed, please take a moment to do so. Also, if you haven't heard about it yet, the master playlist is where I put all these videos in what I think is the best order. So that'd be a great place to go through. If you have friends that are getting into networking, it's a great playlist to have them go through. It starts at the beginning with what's a server and a client, and then it goes into layer 2 switching, and the race is on. Video by video by video. You might want to spot check and see which ones are interesting to you and which ones aren't. And I've been talking for 11, 12. Wow, I've been talking for 11, 12, 1. I've been talking for almost 2.5 hours. So when I have a chance to meet you and we talk in person, we go grab a beverage or hang out. If you come to Vegas, it's not like this. I'm not just one-sided talking. It is a two-way dialogue. And I kind of feel that with all the chats going on. I feel like I'm not monopolizing the discussion, and I care about what you think, and I care about if you're doing well, and I want you to succeed in Cisco and networking. It's been incredible for my life and my career, and I want that for everybody who's willing to put in a little time and effort to get that. So, all right, let me just take one last peek. Fantastic. All right. Thanks, everybody. We'll see you in the next live stream. Bye.
I've been waiting all my life for someone like you. I would watch the days go by, wasted in blue. I was out of use. Now every day